Welcome. Sorry for the late start, everybody. Let me just check and make sure everything is coming through fine. Everything's looking good. All right. Yeah, sorry about that. We had some medical things that needed to be taken care of this morning, and we had to make a run off to see a doctor real quick. We are back. I don't know if we're going to be able to do a full stream today, but I figured we can hop on at least for the next hour for sure, but probably 3 or 4. Get through a few updates and things like that, maybe code a little bit, and then yeah. So for those that are on the Discord, I shared a link to the itch.io page that we created. Let me just get that pulled up for the stream as well. Dashboard. All right. Let me shuffle this playlist. There we go. All right. So if we switch over to our desktop view, hey, little kitty. Hi. Obviously, our itch.io page still needs some work. I guess I can switch to gaming so we can maximize this. So I still need to do some fixes, as you can see, to the menus. They're off-centered, so I need to do some alignment stuff to that. I've got an idea on what I can do there. We can start a run. When we hover over each of our cats, they'll come out of their box. This is our character selector. I still need to introduce a few like animation style things on how I want to handle like the takeover of the cat and visuals and those kinds of things. And we don't have stats for the cats, but we do store a type which controls the texture for the player model. So if we select one, it'll spawn us in. We can set the spawn location in each of our levels, which will be useful for later. And then once we're in, we can run around, do cat things. The rest of this is more or less the same. I made some tweaks to how we're doing the... it looks like I need to make another alteration to it. I wanted to increase the vision size a little bit. I'm noticing that it looks a little off on full screen. So I might want to mess with that a little bit. The lighting is still finicky on what we want to do. The level is still incomplete, but our goal right now is getting things like collision built into it. I need to do the Y sorting so that we get the overlaps correctly and those kinds of things. I'm not quite sure how we want to handle a bunch of things just yet, but we are starting to make some decent progress. I'm hoping today and tomorrow, realistically this week, I want to focus on a bare minimum sliver of content, but our real goal isn't so much content as much as finishing off our mechanics and polishing the existing things. Like you can see our little animation where we have 2 pixels that show up to the right of the cats. I guess it depends on the direction, left here. I want to fix things like that, just to improve the quality of what we're looking at, just, you know, a little bit. Things like shadow shouldn't block the cat's head. That's where the Y sorting should be coming into play. This is always going to be a weird one. I think I'm going to have to tweak how we do shadows a little bit. Maybe do it as, instead of a solid shadow shape, it's you know, 2-layer with 1 directional on each and stuff like that, so we can actually see the walls and yada yada. So yeah, there's still a lot of things we need to do. But yeah, we're getting some good progress in. The main goal for this week, today through Friday, if I get some time this weekend, the weekend as well, our main goals during this time period are going to be focused on getting the game into a solidly playable state. So think mechanics. Polish isn't really a big concern. I know I added a lot of animations and things, but they were existing sprites, and so I just had to wire them together. In order for it to function correctly, I already needed it in, and to know it's working, I already needed it in, an animation tree and animation player and those kinds of things. So it wasn't really much of a difference spinning up, a proper 6 texture sprite with timings on it. It's all in, the difference between that and a single sprite for each of those is a few seconds. It's not a big deal once everything else is in place. But we can swap out the textures later if we need to. But yeah, this is where we're at. We don't really have we do have an in-game menu. Unfortunately, it requires escape, which is also how you close out a full screen. It has the same problem because we're using the same menu structure. From here, we can, of course, resume. It's got keyboard support as well. So we can tab through those, and then if we want to abandon, cancel, quit, cancel, stuff like that. Quit is a little finicky on web. There's not much I can do about that. That's just the structure of how itch.io handles web. But if we go to abandon run, we're back on the main menu again. I know what I need to do to fix this, so that should be a pretty quick one today. We don't really have anything in settings so far. I just scaffolded it out and added the hooks and stuff so I can render settings. But if we start a run, select our cat, and then we can quit. You'll see the I can't tab or control anything because the game has been stopped. It's itch.io's web player though, and so it's just kind of in a it's kind of in a brick state until I refresh. That's just the nature of how quit functions in itch.io. It would be nice if they updated it to where when you got a exit command, it went back to this or something. But yeah, let's just pop it back out of this. Let's switch back over to our standard desktop view. All right. So let's start by tackling the issue we were just looking at on menus. There's our logic tie-in, our hook for how we place the player. Menus. So we can recreate it here by full screen. Yeah, perfect. All right. Hey, little kitty. So this is this is the scene for the backdrop, which I want to add something to the main menu to make it a little more interesting. If we go to the actual menus section, I had originally planned on making each of these their own menu and figured out a way that I can handle all of them in one so that we can reuse logic anywhere that it's relevant. So that's what we have now. The changes we need to make are tied to this structure here. The question is, can I use this to align center? That is an option. So if I then delete, actually I should be able to just hide those. It's still offsetting, interestingly enough. I don't have a group on this, do I? No, okay. It's weird that it's centering now because I was using offsets before. That's what the left and right are. But when we maximize, it doesn't update the centering space. If I set the... I think that's going to be an issue. Welcome, Ginger. 7th Street. Nice. I might need to wrap this in a flow. I guess what I should do... Because if we go to game scene, like this is aligned within our space. We don't have any transforms. I wonder if this will cause any issues. Yeah, it does cause issues. I'm not seeing. I thought that might be the case. So I need to set the, if we go to the game menu, if I change this from a VBox container to a flow container, I want a horizontal flow container centered. Okay. I mean, it's offset still vertically. It's having the same issue with a horizontal offset as well. So let's change this back to HBox. What if I do that? Is that they're hidden, so they shouldn't be doing anything. Yeah, it's getting the original width and assigning it. So I wonder if there's a... If we go down here, node this. I need to know if there's a way to determine when the window resizes in Godot. I think that's our problem. GD script window resize event. We have on window size changed. Should be a void. And, you know, when all is that fired? It didn't get fired at all. Interesting. I need to connect it. Let's try that again with that. So if I maximize, should be fired twice. Yep, there we go. All right, fix that. So in here, I'm wondering if GD script resize canvas when GD script, how to tell canvas to resize when window resizes. It should be, based on what I'm seeing, I'm guessing that there's a method to trigger this. Since it's not doing it itself, I should just have to wire that method up. Oh, we might not have to do that. Project settings. Canvas items. This is viewport. The set mode to canvas items or viewport. Viewport is used for pixel art games as it scales the entire viewport. That's what I was using. It's an aspect ratio to keep. That works. Hey, there we go. All right. Our problem is expanding our viewport doesn't expand our available view space, which I guess isn't intended. We could change the viewport initially, but I have it set on the standard 720p resolution right now, which should be fine for most people. I do want to change, so that fixed that ROM, which means we don't need this. And we don't need this. We need, all right, I wanted to change the player. Let's change our point light slightly. We need to alter this gradient. Let's bring this in a little bit, bring this in a little bit, and then bring this in. There we go. Now we don't have that cutoff on the left and right side. It is still cutting off on top and bottom, but it's cutting off because of edge of screen, which is better. I don't want to bring it in too much more, to be honest. I like the main reason we're doing this. I guess I could increase visible area to where you can always see everything on the screen with no fall off. And then still using it as light allows us to block vision around corners without having the max range. Let's see what that looks like. All right, so in order to do that, I want to duplicate this. And then let's change this to be (1280 by 720). And then we'll change this to just have that. We are getting a weird cutoff on the right side, I'm noticing. Like a linear cutoff. So, are we getting on the left? Yeah, I might need to increase the width a little bit. But this fully reveals the screen while still giving us line of sight shadows around corners. Not sure which would be better on this one. So if we make this 3, make this that. Oh, it's stored by reference, not by name. So if we go to player, I somehow managed to change it on both of them. It's because they're sharing a texture. Okay. I feel like this looks a little bit better, to be honest. Mainly because it gives the, I think it focuses it on the character a little bit to give it a bit of a glow effect. I also tried adding some easing to the window, but I was having some issues with that. So let's go, or to the camera. Let's go to that and let's smoothing. It's not as bad if I increase it more, but you can see it makes it real jittery. And it gets less, I don't know if you guys can even see that, it gets less jittery if I increase this, but it also doesn't do anything once it hits a certain point, while still adding some jitter. Oh wow, that got worse. Let's do 5. This is actually a reduction. Still gives that fuzziness. I don't like that fuzziness. This is the default. The only other thing I can think to do would be create a camera offset based on the direction the player is running, so it goes ahead instead of trying to smooth behind. And then we can snap it initially, lock it while moving, and then lerp it when it resolves back. That way it's instant when you try and move. All right, let's remove smoothing. And then we'll add can we override a setter on a default variable? Redefine original. We can't redefine. Okay. Makes this a little more complex, but I guess we'll just do it this way. Physics process. Every time we update velocity. We want to set, if we go here and we check the transform, we can set the position. This should offset. Okay. So we want to set this dot position equal to velocity. This won't lerp, but okay. Just snapping. Okay, so if we then take velocity normalized times 10. What if we then dot move toward. We want to take the current and move towards the new. Dot move toward with a given rate. If we reduce this rate and increase the distance, it should become more noticeable. I like that. All right, let's set this to, say, 3. Stick with 15 for now. Maybe we up this to 25. I think that shift is too much. It becomes hard to control at some rates. So 20. And let's snap this a little bit quicker. Yo, welcome. It feels a little off. I think it's because of the distance that we're traveling. So let's drop this down to 12 and up this to, I'll leave it at 4. We've reduced this actually down to 2. It looks much better when it's resolving back on the slower rates. So, but I also don't want it to, okay, so let's do a differential in change based on whether it's going up or down. Let's also add a bit of a slide effect. It's times 3.0 divide 4.0. And then we'll change, we'll add this line here and here. Oops. So in the first case, this is when we're zeroing. So we want this one to be low. And we don't care about this because it's resolving down to 0. So we can actually do vector 2.0. Yeah, let's leave it at 2 like we were doing before. And then on this case, let's up it to 4. And let's offset it by 15, I think. Velocity move towards, let's set this to 5.0. I don't think it's working. All right, it is working. It's just, this isn't enough. So divide 2.0. It's still too fast. Let's divide 3. Still pretty instant. Let's disable these real quick just so I can test this a little bit easier. just make a big jump, I guess. Just double it. Too much. Halfway point between those two. I want it to be just at the edge of noticeable. I think 10 might actually be our winner here. Let's try 8. And it's hard for you guys to see. Because I'm able to tell it based on when I let off. Yeah, I was getting, so if I, here. Right now what I'm trying to do is get some smoothing on the character stopping. I want it just at the edge of noticeable. So it doesn't feel off, but smooths out the speed transition. It doesn't just like jerk to a stop. But this is what we're working on just a second ago. So if I re-enable position smoothing on the camera. Actually, let me crank it up to the worst case scenario for you guys, just so you can really see what I'm talking about. Because I don't know if it comes through on the video quite. Here, I'll watch the... Honestly, with the... you can see it a little bit, but with the compression, it's kind of hard to tell. Was it like 50 or something like that? It cranks up to where it just looks like minor teleportations constantly. No, it's the but you can kind of see it gets like fuzzy around the edges. It's jittering as it goes. If I crank it down, it reduces it a little bit. It's still fuzzy around the edges as it's moving, but not great. If I turn that off and I turn on my position changes, this will actually move the camera ahead, and then we're doing a little bit of lerping on the positional movements with a faster speed when you're going in a direction, so it'll jump ahead of you a little bit quicker, and then a slower speed once you stop, so it smooths back towards you. I could add delays and stuff like that, and so you can't really notice. It just kind of jumps ahead instantly when you change directions, which is what we want. And then at the end, just you notice it shifts back on a smooth basis. You can notice it really if you watch the like the shadows at the edge of the screen. Yeah. LERP is a linear interpretation as well. Difference being is you can change the algorithm that gets passed to it to make it like a, you know, some sort of curve. The default is also linear though. I am tempted to switch to an actual proper LERP just so I can change the curve on it, but yeah, I might as well. I'm gonna have to look up how to use the syntax for a GD script on LERP though. They actually have it built in for position. Perfect. So I can just run, which also looks like they might be using a non-linear then. Lerg. Close enough, right? LERP. All right, and then T is delta times 0.4. So it's a fraction on delta. Interesting. How do you provide We'll just try it as is and see what happens. That's what we wanted, right? Cheated. Okay, so we definitely need this to be a... well, let's look at this way. Let me go back. What's the definition for this? Come on. All right, well, I'll look it up over here on the docs. There we go. Interpolation. Okay, so I need to change, in order for lerp to work, I need to create a variable to store the lerping rate in as. Interesting. For cubic, blah, 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 and what to do Bezier style. So for cubic interpolation, there are also vector to cubic interpolate and, okay, which use Bezier style. So there's a built-in, yeah. I need to have this be a delta on this if I want it to do, 4 over a second or whatever. So I need to track delta, and I can set a rate for it and stuff like that if I want to slow it down or increase it. There's instead of lerp, which is linear by default, we can do cubic interpolate, which will use a Bezier curve instead. Again, I can't get docs on that though, which is weird. But we'll go back to the lerp process. And I want to set this to be got it. So if I do something like 0.4 in each of these, the numbers are off from what it was before, but it's doing the exact same thing. And so in theory, we should be able to swap this to cubic interpolate. What's our expected 4 arguments? So let's check vector 2 dot. They renamed it in 4.0. What are expected 4? Control 1, control 2, end, and float. Okay, well, I don't know what control vectors are. It also makes me wonder then, based on the error, is this a valid function? It is. Okay. Between this vector and B, using pre-A and post-B as handles. I'm gonna have to look up an example of how they intend to use these. Let me see if this has an example code for the code. Performs a cubic interpolation between this vector and B using pre-A and post-A as handles and returns the result in position weight. Weight is the range of 0 to 1, representing the amount. It can perform smoother interpolation than cubic. Okay. This is literally docs. I was hoping they would link to an example in their docs page. So let's do a GD script. Vector to cubic. Interpolate. See if I can get an example of this. So popping back to here, the current position equals start position dot interpolate. So that all stays the same towards an end position. What I need to figure out is there's supposed to be two more variables in right here. That's the handle in, handle out in this code. Control point pulling down from start, control point pulling up towards end. So this is the points on the curve. You get 2 points on the curve that you can fiddle with. Interesting. I'm just going to grab these as is and see what kind of values it gets so I can get an idea of what we're working with. This needs to be a vector 2.0. First, I noticed it's immediately offset the camera, but let's reduce this down to vector in. So this is the initial shift. Let's do. So if I understand this correctly, if we do something like a negative 1.0, and then we can snap up to, say, a 16.0. I don't know if these are normalized or if I need to handle normalization in addition of the vectors to get this curve to work the way I want. Oh, right. I should probably add this to both. So let's zero out the initial on. So this is the initial. This is our in. So when we initially try and start zeroing, or sorry, start transitioning to this, we want. I got this backwards. We want this one zeroed out. So when we initially want to stop, we will do a flat line into a curve that snaps a little bit past is kind of the goal here. And so if we're doing a 15-point offset, let's bump this up to 30 just so we can get the exaggerated version of it. And let's transition it over a longer period. Again, this is changes to slow down. So when it stops. I expected more of a snap back than that. Let's up this to, say, 60. Oh, that should be 6. Also, it's at an angle, so we definitely need to change it based on... Okay, so if we take the position, normalize it. So if we grab... Actually, the position is the current velocity. Based on this. Oh, no, we should probably just use this just to be safe. So if we take this position... and we normalized times 0. Again, I don't know. Let's do this. I want to know what the impact of it's going to be. Actually, we don't even want to normalize it. I don't know if this is relative to the position or if it's relative to a 0. I would assume it's relative to a 0 because you're defining a curve, but I don't think it actually is. Let me drop this in and test something real quick. And then I need a short break normalized. Again, let's do something extremely exaggerated so we can see the effects. Yeah. It's very jittery once I stop moving, I noticed. If I reduce this down to, let's say, 10. Actually smooths it quite a bit. All right. And then we want the pretty much the opposite on this one. So if we grab, actually, I don't want to grab that. Let's do, this is the position we're going towards. We want offset by 15. Then we transition across an initial variance that we will do as we want the, let's do this times, let's jump it immediately to, say, 5. And then we will normalize it out. Actually, then let's do vector 2.0 to bring the curve back in. Yeah, we do need this. Boom. I don't have the same effect. All right. I'm going to take a break for just a moment with this ad. I will be back here in a few minutes. Hi. Sorry about that. That took a lot longer than I had planned. We got some life stuff going on right now. My partner is having some health issues this morning. She's feeling a lot better now. And wanted to go over to her friends to hang out for a little while, and I managed to misplace the keys, so I had to go hunt them down. There you go, little kitty. But we're back. Hi. So we got our curve set up. Masudi, I didn't see a message. I saw a notification saying you sent me a message, but when I popped it open, it was blank. I didn't actually get a message from you. Can you? I did accept your friend request though, so you should be able to send me a message now. I'm not sure why it blocked it before. If you want to resend your message, and I'll take a look after stream. I just want to make sure our diagonal and verticals are working as good as our horizontals, because I spend a lot of time running back and forth to test these things. I think that looks pretty good though. I do still want to slightly fix our ending. So I'm going to these. So if we can apply the same logic we did here up here. So let's take pretty much this. Let's nope. Duplicate this line. We will comment out the original. Pop that in. All right. So we are heading to 0. I think I'm gonna have to do the same here as well, by the way. But we're heading to 0. That is the goal. So velocity moving towards 0. This is grabbing the current position to flatten out the start of the curve, and then normalize. Okay, so we want to change this, because this is our start. In, out. And so we want this to be something like vector 2. Right. We need this to be a normalized version of current velocity. Normalized. So this will get us the same direction facing. And then let's just multiply this by 5 for now. And then let's do 0.1. I want to see what it looks like. It smooths too much at the end. Okay. Let's take this as speed divided by 10 to be a little bit closer to what we did here. And up this to 2. Okay. I don't want it to be this big of a curve differential. Oh, hang on. Whoops. Hey, Edgar. Don't worry, buddy. Just make yourself comfortable. Just move whatever's in your way out. That's fine. That lasted all of 10 seconds. So that is giving me the curve I want. It's just the ending part that we're having an issue with. All right. And it's probably tied to this, to be honest. If we make this smaller and increase this, will it smooth out that last bit so we don't get the jittering? No. It also snapped in a lot faster. So let's go back to 10. I'm using a normalized velocity here because I want the curve to be in the same direction so that it hits that point and then slows afterwards. Maybe we need this to go to... I wonder what happens if we just set it to vector 2.0. In my head, this is a lerp. We just flattened out. Well, technically, we would need these to be on the line between the two. This should just snap in the middle. And if we do this, it should maintain longer. That was the opposite. Let's do this. Yeah, that is effectively removing our curve. It's just shifting to the beginning or end. So we want something, we want both these points to exist between. It's wild to me these aren't normalized. Yeah, let me see if I found an example thing in here that's supposed to be explaining how this function works with images. That helps me usually. All right, so seeing you can test out the function with the drag and drop. Click on the image below to see the, nope. That's not what I want. Yeah, so if I understand correctly, what works with A-Sprite does. I need to find new file. Actually, I just installed something that might actually be working with this. Let me try draw. Let's see if this will work. Let's switch it to landscape and snap to the side. Let's see if this is going to work. And then correct me if I'm wrong on this, but if I'm understanding this correctly, I need to switch to the draw. I just need to remember what the draw one is for this. This is it. All right. So if I'm understanding this correctly, we've got our point 1. What the hell? All right. This is what I want. I can repeat draw on here. Okay. There we go. So we have our first point, and then we have our what's called in, which I'll put in here as our second point, and then we have out, which is our third point, and then we have our end point, which is our fourth. This is technically, this is the method we're calling it on. This is the first parameter passed, and then this is parameters 2 and 3. But if I'm understanding this correctly, the concept here is that we have a start point and we have an end point, and a lerp is just your points 2 and 3 are where these sit. That's effectively what we're looking at. But what we want with our curves and stuff that we're trying to do is we're trying to set a point in here on point 2 where it's like, let's say we wanted a, oops. Let's say we wanted something that looked a little like this, where it went down and then up and then over. We need to set point 3 here, and we need to set 0.2 down here along this curve. And that will get us the Bezier we want, which means that this needs to maintain it's not a time-based function, which is what's throwing me off, because Bezier curves are over time. And so this needs to take place over a set time period. So this is, damn, I don't know why it keeps switching on me. I'm using my pen right now, my stylus. Sorry about that. And the built-in draw program was being finicky with it last time I tried. I need to fiddle with it again and see if I can get it working. This one's also having finicky problems. The only program I have right now that works consistently with it with 0 issues is, oh, except I just pressed a button. Sprite. So I can do all this with my pen, no issues. But it also means I'm using Sprite to do non here we go. So something like this. So we got start point, curve that we want, end point. Those are easy for us to get. It's the points here and here to make this curve work. But we're given, like, this is our, you know, P1 dot interpolate on P4, P2, P3, and then T. So the only thing I can think is that this is trying to step, like, time 0, time T1, this one would be time T2, and then this is time T3. And so it's transitioning between these points like that, maybe. Which means that if these 2 points are the same, it just gives 1 tick here. And if these 2 points are the same, then it gives 1 tick. Like, it ends the 1 tick earlier. And this just tells us how... I'm not quite sure. Yeah, what's throwing me for a loop, though, is you would assume in every one of these scenarios, you would start with 0, 0. And then you would provide some point that is like a 1, 1 or something like that. Technically, in the setup, this would be a 1 and then a -1. And then you would provide along your curve on the same scale that we use everything else for, down to like a -1, 1 or something like that, and then a +1, 1, and it would just be tick based. And that way you can define the curve that's going to hit, and then you're just stepping down this curve. What's throwing for me for a loop is the fact that these aren't meant to be on this scale, because it's all taking into account from this point. You know what I mean? That's what's getting me. Oh, that's much better. That's where I'm messing up on things. Because that also means that every time I want to draw one of these curves, I need to now normalize these not against a normalized vector, but I need to normalize these against our start and end point. Okay, so you're saying that it is performing like we showed before, but it's doing it as this whole snap, and then it steps along this by our step. So if this is meant to be occurring over a 1 second period from point to point, and I give it a 0.1, it'll move 1/10 of this distance, and that's our new point, and then it will redefine our curve. Is that what you're saying? Because then the next draw is going to redefine this as a slightly changed curve, and then it'll move 1 step along it and then draw a new curve, and then step along it and draw a new curve, is what you're saying. Okay. So in order to do what I want to do, I need to pretty much define this over here and drop it in as constants outside of my physics so that I can get everything working the way I want it to. And then when it comes back and I need to just set velocity, then I just find, what is the current value that's being iterated out of it based on the current step, and dump this, normalize this value back to what it needs to be from a velocity standpoint. That seems like a lot of extra added work for something that should just work this way to begin with. Like, I don't see a scenario where this actually makes sense to use in this fashion. Okay. Well, let's think through it then. So if we can if in that case, we can define our curves inside of functions So if I understand this correctly, this is moving 0.4 along the defined curve here. It's moving 40% away of the way from this point towards this point along the curve defined as this, which is literally just going to be a drop to 0 and then a flat line, essentially. So I'm going to get the 0.4 of that. I'm going to get that drop going down, and then it's going to flatline, essentially, is what's happening with this curve, with this definition of it. Then it's going to jitter at the end, because its next step is going from 0.4 to 40% of 0.6. So it's 40% of 60%, and then it's 40% of that, and then 40% of that, and so on and so forth. So what I really want to do is add to it every time. And if I wanted to do it over a second, it would be times delta. And then I'm actually doing this on t, and I'm passing in t here, where I store t somewhere. And so what I can do is I can calculate your position along this curve consistently. So what I can do is I can write a function. Let's say this is a func easing, and we want to provide we get these, we provide a endpoint. No, we don't even want to provide that. We want to give this function internally everything. And so it just takes in your time and returns back a vector 2. And then let's get a easing curve as 4 points. We're going to take in a vector 2.0 as our start point, do a cubic interpolate, and then we're going to provide the destination as a vector 2, 1.0, 1.0, and then we're going to step along the curve as let me grab one of these easing functions. Something like, so if we're doing 0, 0 as our start point, vector 2, if 0, 0 is our step, we want to move 0.5. No, let's do a 0.3 or something like that. 0. And then we'll transition to, actually, we want to bring it up a little bit. So let's do a 0.31, something like that. And then we'll snap up to a vector 2 of 0.7. 0.9. I want that more drastic, I think. No, it's fine. And then we'll snap the final thing to this. And then we provide it a T. And this will return back return. This will, given a time that ranges as a float from 0 to 1, we will find where you are on this curve, starting at 0, easing up, and then jumping, and then easing out. So this isn't, technically this is an ease in, ease out. And then at any function we want to run, we can run a var dir t equals 0.0. Yeah, I'm starting to think I might want to use a tween instead for this, but tweening on things like velocity gets wonky in my experience. But given that, we can take velocity, set it equal to easing of, yeah, that's the main problem. Set an easing of dir underscore t. And then we can do dir underscore t plus equals, let's just keep it with underscore delta for now. I'll fix that in a second. This should provide it in a as a normalized vector. And then we just need to get the directionality. But if we multiply two vectors, it doesn't actually multiply across. It creates a dot product in Godot, if I remember correctly. What happens in GD script when you multiply vectors? It doesn't create a vector. It doesn't create a dot product. Sorry, it creates a scalar. All right, is the equivalent of A times C. B times D. No, this is supposedly correct. So I should, in theory, be able to multiply this by velocity. And this becomes a... This will work correctly because I'm trying to go to... No, I'm moving towards 0. So this won't work correctly. It would work correctly in here, though. So I need to... We've got ease. This isn't ease in. And so we need to duplicate this. Oops. And we can create an ease out, which we need to invert these. So this is a vector of 1.0, 1.0. And this is a vector 2.0. And then we need to take this, drop it in here, and take this, drop it in here. And then we need to change this to ease out. Yeah. Ease out. Now we do need to correct this. So we want to set when we change direction. So if velocity changes, I'm going to get some wonkiness with our transition point between this when we shift angularity. But if we take, let's move this line. I think we actually want to set this beforehand so we'd get the first point along this curve anyways. So let's do that. And then we need to know velocity equals that. So we want to know if this should be normalized actually. So if we, just to be safe, normalize this, and then we check and see if direction dot is approximately equal to velocity dot normalized, then we can set this back to 0. So if they, if they're not equal, we reset. Okay, that's not quite what I'm wanting. This should be going, I think I might need to clamp this. This 0.0, 1.0. It's never quite getting to the end is the problem. T. Oh. I want this to end with a 0. This should be our end state. Or did I misunderstand? Pre-A, post B. This between this vector and B. I mean, correct me if I'm wrong, but this should be the next point after A, and this should be the last point before B. So A, then we shift in, and then B, or sorry, the post B and then B. And so this would transition us from 1 along this curve to 0. I think it's my multiplication here, to be honest. So let's our easing are essentially 1 in both cases. So I might need a snap there at the end. All right, what I want to do is pop that and then close. It's always coming back as a 1 is the problem. Oh, here we got some. All right, I'm just gonna snap this back to the move towards so we get the lerping for now. I'm gonna have to think about this for a little while and fiddle around with some things. I want to focus on functionality for this week, and getting lost on these tangents isn't gonna help. So let's just clear all of these out, and then we can swap these back to a move board. That. I want to focus this week on, like I said, functionality and getting things in place. And then next week, I want to work on more polish and levels and things like that, since we have a 2-week run for this one. Let's copy this down here. We want to do. This is our target. Let's go the opposite direction with that. And then I want this. Oh, we'll come back to that in a second. And then we'll change this to be a little bit faster and this to be a little bit faster. There. That feels good enough, I feel like, to get us through quite a bit. And that way, even if we don't get time for polish, it's not terrible. That's kind of the goal I was going for with this initially. So they should get us, you know, good enough. And then if we get time at the end to improve things, this is one of the things I want to improve upon. I got distracted with this originally. There was something we were working on before we even transitioned to this. We were initially looking at. All right, this is centered now, so we did fix that. I made a list of things we need to do. So I fixed that. Rendering in smaller base size and edge. So we fixed that. Back to our issues tab, and then if we look at player character, those are improvements. Let's jump to level structure. All right, so I want to improve this screen, to be honest. Well, first off, I want to improve this. I have the background stage for this, so we can improve that. That's not a big deal. It's just figuring out what we want on here. Also, I can do like logo and title and stuff like that. This is the screen I had in mind, though, for improving. Also, I'm not sure if you guys have noticed this yet. My selection animation, they'll come out of the box. I'm very happy with this. If you hover over them, they'll just chill there blinking. Cat selection is in place, which gives us a type which controls our texture. It also is all the hooks we need to control stats. So we can, any stat you can think of, which means we could, since we're adding like lerping and stuff, or we just added it, we could change the numerical values on slowdown to make movement a little, like, you know, ramp up speeds, ramp down speeds. We can change max speed, things like that. Those are all things we have control of as well right now, but we could do it through the character selector as well. But I want to incorporate, when we get to that point, I want to incorporate something in the center that when we hover over one of these cats will change. So that I'll say, you know, what it is. And then I want to change it to where instead of clicking on it, activating, we have like a select state, which will trigger the cat coming out of the box as well. That way we can add keyboard support. We also need to fix stages. So they're actual stages. I was creating our collisions and our occluders and our AI meshes, our navigation meshes, are all in the tile set itself. So we can create stages pretty ad hoc now. I also added a level selector so we can toggle between them. But if we go to level 1 in here, this navigation mesh is a distance from this tile as a, because this has an avoidance on it. And so adding a wall will create a new, and then rerunning the baking will separate things out. So if we go to the wall tiles and we find this, let's paint across there and then save that navigation mesh, bake. So in order for us to add obstacles, we merely need to rebake our navigation region, which will save us a lot of time in the long run when it comes to creation of levels. We can save that, and then we can just go here and we can bake. That'll be huge for us because this also means this unlocks everything we need to procedurally generate our levels. All I need to know is there a way for us to bake navigation regions after we create a scene dynamically? And if we can, all of this will work as is. We just need to be able to set our region. And technically, I should be able to do something like this. And yeah, it'll expand all the way out. So all we need to do is set our points for the, because we can add as many of these points as we want. We just need to follow the outer bounds, to be honest. Or we can do something like if we do wall layer here, we can run walls. Oops. That should remove, yeah, it separates it out. And so we run into the issue where technically you could run an AI through to give it a point here and it will attempt to navigate. But if we did, you can see what happens on that. So if we go to our enemy scene and we set up our navigation agent and we turn on its debugging mode so we can see where it's trying to path to. Let's grab a cat. see what we start getting. See how it's trying to, this is the end of the navigation mesh, so it doesn't know what to do. But it can't, it got this point knowing it can go here. But now it can't see us, so it won't update points anymore. So it puts it in a weird spot where it's in a pseudo navigational phase, but I think in the end game, I'm not going to do walls this way. We have a lot more shapes that give more variability to it. That's what we should do. We should add the one last thing to our shapes, which is Y sorting. So let's get our Y sorting set up. So if we go to here and we want to paint in a wall, a proper wall, let's get a corner on it. And then we will do a length of wall. And then we'll corner it this way. We got that length of wall, and then we want to run a wall like so. Nope. Where is this one? Something like this. And let's get rid of these. Let's get rid of these. All right, first question. Do I have navigation layers on these? I do, perfect, okay. So this will block our navigation just like before. Let's go back to wall layer, and then we need a endpoint for this. So we'll do something like that. And then we need a start point for a wall. So let's do something like that. And then we'll remove the tile in the center. Now we can do is just an ending wall. Let's run a wall across there. Something like so. We need more room between these to get AI to run through. My intention on this was to originally do something like 3 wide walkways. With this, we might do a 2 wide, and that might actually work, but let's give it a try. So if I grab this, I shift it down 1, and then we bake the region. Will it go through? Yes. Okay. So let's see if they'll chase us through there. I need to set our player position. So let's update player position now that I've got stuff in the way. So this is 480 by, we'll say 145, negative 145. So here, 480, negative 145. There. So we can go between these. I need to change how I'm doing the shaders for these walls on where we set the shadows at. So will you chase me through? So the chasing works through those, which is good. I just need to know, can I, because if I add a wall, something like this, I just want to dump something in to break. And I run this. If we go up here, they stopped. Interesting. Because that shouldn't, this area shouldn't be baked in. Yeah, it's not trying to navigate around it. But also I went all the way to the bottom, so that might be an issue as well. There we go. Let's try that. if I can get them in a state where they should be able to pass through, but they can't. Actually, I know what I need to do. Let's bake this, then remove these. They should be able to walk through here now. But because it wasn't baked with an update. Yeah, it's pathing them all the way around. That's what I need to know. So now we've got a scenario where it's an issue. So we'll pop into our script and func. Ready. Grab a navigation layer. Ooh, we need to do this at export of our we're gonna do it this way. Nav region. Navigation region 2D. And then we will set our nav region. Let me save this. We'll set our nav region where export var nav region. Oh, there we go. Okay, nav region, drop it in. All right, now let's do nav region dot bake navigation polygon. I can provide it a thread. This will run it on a separate thread. Is it, wait, is it the default? It is the default. Okay. We'll just leave it as the default though. So now, hey, it's updating. Boom. That's what we wanted. This means we can procedurally generate levels. I want to do a custom waveform collapse algorithm. I'm gonna wait until the ad finishes so we can talk about this. All right, ad is over. This works, which means when a level renders for the first time, it will bake its polygon navigation mesh. So as long as we have a region, a bounded region provided, which we can do this programmatically. I will change this at some point to not use it as an export passed in. It will, like, we'll probably have something like if nav region equals null, then create nav region. And then we will populate our nav region. I want to utilize this combined with all of the stuff we've done so far to create our wall and floor layers. I want to collapse it down and then use that information on a waveform to create a custom waveform collapse. And the reason I say custom is because we can, with a waveform collapse, it's a fairly simplistic algorithm conceptually. It's the concept where you have an area, you pick something within that area, like any cell within that area that you have available to you. You have one of in options. You randomly choose one, and that is now your start point. To the 4 cardinal directions of your point, or you can technically do diagonals as well, if you want. But every direction going out from that point then has options that it could possibly be. Those options then get reduced based on the first point. So if we bring back up our board, let me grab this real quick. Is there a good way to... I need to fiddle around with some of the other tools to find a better way to do stuff like this. Oops. Actually, I think I have that key bound as well. All right. So the concept here is fairly straightforward on a waveform collapse. If we have, let's say we have tiles that look like this. It's an interesting... We've got angled tiles going to each of the directions or something like that. And the goal here is, you know, we render these tiles as corners, and then we have a solid. If these are 5 tile options, then the variables are fairly straightforward on what you can and can't do. Normally, you would also have something like another tile here that is a... So you'd have pathing tiles and non-pathing tiles, and then you would have, you know, this area that's blank here as a non-pathable area. So now we have 6 possible options that each thing could be. You create your region, you select your start point, and then you will fill this in with one of the possible options. And so let's say our algorithm first starts with something like this tile. Now in our logic, we'll say this is now a connector side, and this is a connector side, and this is a non-connector, and this is a non-connector. Well, when we write this, our tile sets, we'll say these tiles have connector sides, these have connector sides, these, and these. And then this has connectors on all 4. And this one has no connectors. We now need to find, this can be any tile that has a side connector. So it could be this one, or it could be this one. So those are now our options that could potentially go here. Boom and boom. We also have this one. And that's it. No other tiles can connect to this side. On the flip side, we could have any tile that has no connection on the bottom. So both of these tiles, as well, or I guess all 3 of our bottom options could go here. So, boom, boom, and boom. Something like that. This is now the options we have within our capability for moving. We, of course, would do that for the options here, and we do the options here as well. Then we would go to the next tile over, which it'll choose of these 4, which of these has the least options available to it. If there's all the same, it would randomly choose one among those options. We will choose this one, we'll say, and it will resolve out to, let's say, oops. Let's say it gets the full square option. Well, now we've got connectors on these 4 sides. And so it will go through and do the same process, filling in options for this guy, options for this guy, options for this guy. It then searches all of the available ones and repeats that process. Normally, this would be done with your entire space. That is a terrible straight line. The entire, that one was just bad. The entire area that you have would be available to you. I can customize that though and say our start point is always player start point, and our player start point has to be a navigatable object, which already collapses down what options are available in each of these for our player. We can also say things like, we can only go, you know, this is the edge of the board now. And so this would get no option available to it because this is always the edge. We could actually, you know, place a door or whatever here. And then we can resolve back that this going up, X distance has to be a wall. This going down, X distance has to be a wall, so on and so forth, to give our start point. That will resolve back the options for these tiles along the edge and the tiles immediately around our player's start point. We can then go a step further, and instead of collapsing the entire area, we can ignore area bounds completely, because within Godot, that doesn't care. Our area will expand if we need it to. And what we can do instead is we could do the equivalent of a marching style, where we define parameters saying hallways are 3 wide. And so we create 3x3 chunks because we want our hallways to be 3 wide. And within the bounds of a hallway, we decide that a hallway will be a wall or a wall with a door on the bottom. And we can do a wall, it'd be up to, so we can get that. We can do either a wall or a wall with a door on the top as our tile set. And so this would be a 3 tall tile. And so this would, technically we don't have to do this. These could be floor tiles. You know, all of these. This is what we define as a hallway. And then we create chunked allocations for what we want our segmented chunks to be. And so we can do a high level marching algorithm that says we have halls of shaping, you know, vertical or horizontal, variants of 1 or 2 for each of these. And now we can generate out a series of hall styles. When we have a hall, it can resolve in different ways. And so we write all of that into our waveform collapse. And now we can generate 3x3 chunks. And instead of doing it as a standard waveform collapse, we have a designated start point and a marching. And so it would take that start point and it would move along in our 3x3 chunks, defining what they should be. But then within each of these chunks, we can go further and set boundaries on how they should resolve to give some variability. And so we can waveform collapse within our waveform collapsed chunks. And this would give us it would take a few iterations to get it down on creating it, but it should be fairly quick if we do it in a marching order. And then we can bake that mesh to get our navigation. And this would give us an ability to shape our procedurally generated areas into hallway style focused with designated start points, end points, and whatever we want to cross them. Because we can then say this will waveform collapse in a hallway. This hallway could potentially have an enemy in it in one of the 2 upper corners. And we can have, on this level, we can have up to 5 enemies across the entire thing. And so when it collapses, if it chooses to have no enemy here, but it does have an enemy here, it would then tick this down on the remainder of the algorithm. And so the next hallway chunk has 1 less chance across all possible locations an enemy could spawn. And so we would do something like that until we have all the enemies we could possibly want with intel on how they should be spawned into a given chunk style in order to work with that chunk, which would give us a lot of benefits. It's a lot of words, but I think this will give us a good way, because it gives us a good option, because it gives us the ability to do start point, end point, effectively draw a realistic path between them with possible deviations. And we can say these deviations are required to always loop back onto the original path, so that we get room style structures. And we could also then do, so if we have hallways, they don't have dead end hallways. And then we can provide, smaller rooms that will enter onto the path and build out as such. And so the only way to get dead ends is through rooms, not through hallways, which gives us a lot more variability, because then the hallways can be, surrounded with rooms on all sides if we really wanted to. So we can actually define entire chunkscapes, so which would allow us to do effectively points of interest. So we get our start, we get our end, and then we can say, oh, well, this segment is a corridor POI, which means there's 0 enemies. There are, maybe we spawn a box, and there's no deviations from it. This next chunk is a cornering POI that is required to have some sort of specialized room in it that contains a power and stuff like that. And we can say there's going to be 1 of these, there's going to be 2 of these, or maybe we load in one where it has 0 of these, stuff like that. And we can do all of these variants on our stages, and we can scale up the numbers on what kinds of POIs should and shouldn't exist based on the level you're on, which also allows us to procedurally generate boss rooms. So if we wanted some sort of, I'm not sure how we're going to do bosses yet. I think that would make sense to include them. But if we wanted to include some sort of level 10 is a boss room. We know boss rooms need a start point that leads into a large chamber, which has some sort of exit. And this is the dynamic for a boss layout. This large chamber will contain, X number of chunks within it. Each of these chunks can be under parameters. And so like the center chunk or whatever has to be an open space. These outer chunks can have pillars and obstacles in them, like desks and things like that, but they cannot be enclosed. So if we introduce a wall to one of these chunks, it needs to be on a single side and the other side needs to be open. All those are things we can do, so we can procedurally generate our boss rooms as well. And then we can put parameters in here saying, when we choose the boss, each boss would be defined based on parameters associated with the difficulty, so what level you're on. So maybe we have 2 bosses that can be choose from at level 10, and we get 3 bosses at level 20. But we can do not only will stats change in the boss as you go to higher levels, like they move faster, they react faster, whatever we happen to do, to scale with the player as they go deeper into the run. But we can also define, well, I don't know. Let's say we have a scientist boss that has, it would spawn in, and when this boss is chosen, we would know you're allowed to have 3 blockades, 2, what I've kind of been referring to as obstacles, which is things you can go, or sorry, obstacles are things you can go around. Blockades are things that the player can go through, but the enemies cannot. And we'll have 1 box or something that exists within there. Whatever parameters we want associated with this boss. This would then derive how we generate our boss layout for that world. I feel like this would be a pretty flexible one. For simplicity's sake, I don't know how much of this kind of stuff we're going to be doing, but I see us being able to do this kind of stuff pretty easily, just doing a 3x3 chunk drawing in a marching style. We might need to cull until outside of, if we want to keep going with this, outside of our game jam for the remainder of this stuff of like the POI style. But this marching style of just chunks of type that can then be themselves collapsed, I think is useful, because then we can waveform collapse as we're waveform collapsing our outer algorithm to take our steps, and then we're drawing the next one, stuff like that. When the algorithm moves on to the next iteration, it can pass what it's already completed to another thread to waveform collapse the internals of it, which can then be used. Oh, it gets weird. Because I kind of want depending on how we do it, the waveform of the collapsing of this might actually determine what this would be. Not just, it's a hall 1 or whatever, but, hall 1 would determine that it has no doors on this side or this side, for example, which should be enough to derive what this needs to be honest. I'm not sure. I'll have to think of that one. But I think we should be able to get a collapsible marching style waveform with as the first pass world generator fairly easily. I don't see this being a terribly difficult thing. A little on the time-consuming side, but not terribly difficult for us. Yeah. I think that might be what we work on today. We're still missing quite a bit on the mechanical side. We need to introduce, the abilities for variants. We need to introduce multiple enemy models and things like that. But our biggest lack in game right now comes from a lack in levels. So introducing this will completely solve that problem, and then it's just a refinement and polish from that point forward. Which, again, is what we want to focus on next week. So if we can get a decent implementation of that this week, preferably through end of day, between now and end of day tomorrow, that addresses one of 3 remaining feature sets that we need. Levels is a big one. I guess content is the main thing there. But let's go with this. So do you want to do that first, or do we want to knock out our controller support on cat selection? Because we have it on menus already. Next week is a big thing. Next week is going to be audio. I want sound effects and background music, as we talked about as well. I think the most important thing for us right now is getting more levels in. And unless I want to just draw a bunch of levels. Okay, that means we need to define what we need. A mapping structure for all right, let's duplicate level 1 scene, duplicate level scene. All right, that's done. We need to separate these out, but the most important thing we need to do first is we need to define I think we can get rid of this. I don't think we ever need to change this, because we can set it to 0.0. use that as our start point and always march out from there. And we're always going from left to right. Which solves one of our problems. We need to introduce you are damn. I need to open that scene. There you go. Level. Let's delete these and add in a node container for enemies. So we need to, in memory, so in order to do this, we're going to need a dict for so we want this to be a marching style. So we need a dict that contains chunk types. We need a dict that will map chunk. In this, we can create every variant of chunk type and include all of the info on how to render. So we can get all the details, which removes our second pass for now, which means we don't need the second dictionary. This would give us the 3x3 chunks that we were talking about that we'd march along. This is all of our options and info on how to render, info on what can go around. So this is all the info we need to choose those within our waveform collapse. Next up, we need an array that will include a collapsible chunk or collapsed chunk. So we get our start point. We create an entry into our array with a collapsible chunk with all of our options. Actually, no, this would go straight to a collapsed chunk because we know exactly what we need to do to start. From our collapsed chunk, which would be an outlier for this, we would just set a limit on one. Limits. So we would create a collapsed chunk as our first entry into the array at this point. From there, we would then need all of the information for this to, which would include things like X point. Technically, we could do this as a direction. Cardinal direction. What direction are we going from the previous? Right? No. We really do want this to be chords. Yeah. We will have to multiply these chords by chunk size when we go to print, but for now we don't need to worry about that. So we get the coordinates of our collapsible chunk type at that location, or chunk type options is the difference between collapsed and collapsible. So we have our coordinates, what it should be. And so as we iterate through this and we collapse a chunk, or every time we add, we would then add it to the array with the coordinate location. Then I guess we could do a dictionary to do quicker lookups on this. My thought process was we would just march through the array, adding as we go. All right. Speaking of ad, Twitch ads are about to start. So I'm going to go grab something to drink real quick, and I'll be back in about 2 minutes, minute and a half, 2 minutes. And we are back. All right. So I think the first thing I want to do is test and see if I can do vectors as keys in a dictionary. So if I can, that solves a couple problems for me. Dictionary. Vector 2. String, it doesn't matter. Oh, right. That's a little weird, but I can't do it, which means as we march away from our start point, we can add to the dictionary. And we just need to track which of these are and aren't collapsed, or iterate through the dictionary every time, which I'd prefer not to do. So we need a couple things as we do this. So this is going to be... This is our chunks. So let's call it chunks. Var. Lowest entropy. I need to create a type. Can I declare types without it being a separate file? Yeah, I didn't think so. I don't want to just store this as a dictionary though. I want to create a dictionary that defines exactly what its keys are going to be as a type definition so that I can refer back to it later. I guess my best option really is to go into I hate to do this. Let's rename this so it makes more sense. Let's call it classes. And then we will create a new script that we will call chunk. And then we will open said script and immediately define your unit as class name chunk. You don't need to import anything at all for now. You will have a variable of size equal to 3. Should I do this as vector? Nah. I should do this vector. Vector 2i 3 3. That's all I need for now. We don't need any of those. We don't need that. Okay. You now store chunk. The lowest entropy is a vector 2. This is a pointer or a reference to the dictionary location associated with given chunk. And then in here, we can define types, enum types, hall, horizontal, hall, horizontal, lower door, all horizontal, upper door, and we've got hall horizontal double door. if we could have this march as like hall points at hall, which points at hall, which points at, you know, room. And then this would be, maybe we have something like room, room, hall, room, 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 hall, empty. I don't know what we put here. Null, whatever. Then we would run a second pass on the waveform collapse that would collapse down saying we have two halls next to each other, so we link them. We have two rooms next to each other, so we link them. And then we create a, instead of a 3x3 room chunk and a 3x3 room chunk, you know, we now have a 6x6 room chunk here. And so that just merges all of our connection points. Then we need to say, oh, well, there's a room next to a hall. Pick an entry point, and then we throw a door there. So each iteration pass of the algorithm would get more detailed. We'd also know room with no outer, so this becomes a wall line on this side of the room. Which means our chunk types will narrow down to hall and room, exit, entrance. And part of our algorithm will tell us if we, when we have a room, or sorry, when we have chunk generation, our entrance and exit need to be linked via halls. This is a hard requirement. And rooms are offshoots, but there needs to be at least one path between these two via halls. And then when we generate the halls, we'll determine how they get linked and everything. I like that. It does mean we're going to get a little, this first iteration is going to feel a little weird. Because it's just going to be, you know, we'll have to choose hall versus room for floor on how we do that, and nothing else will distinguish the two. And if we're going to do that, it might be worth increasing chunk size to 5x5. We'll start with 5x5. Let's see how that looks. Yeah. So we need to know size, var, type. As part of types, we need to know how these can interact with one another so it's not completely random. Which we can do through a switch case. Let's do function neighbor options, which will take in nothing because it knows what it is, and pop out maybe it does take in something. Can we do something like chunks? It's array this chunk, which will return an array of types. So given typed arrays are not currently supported for the rest parameter, so I can't provide a type. But if we set this equal to an empty array, cannot have a default. So we can have it empty, just not provided through that. So my thought process here is we can take in all of the chunks surrounding this. Yeah. Which means we need a way to look up neighboring chunks, which we can do fairly easily with vector offsets. Okay, that's fine. So let's grab type options is what we'll call it. It will provide back the options that are available to you when you call this after providing it the chunk neighbors. So this is all the chunks around this guy. Do we care about... No, because we don't need to collapse immediately. So we can provide bar type options. No, we'll just call it options. Equals... It's an array of types equal to an empty array. This will actually not return this. It'll just set options. That's the thought process here. So you can give this, when you go to create a chunk, you can provide it options to limit, or so you can provide it the neighboring chunks, which will limit down the options it can get. Then we would have a function that is collapse. It'd be a void. This is also a void. Which will take options, pick random. No, we don't want to pick random. The intention here is that we reduce the number of options down as much as possible, and then we randomly pick amongst those. So yeah, that's actually what we want. Eventually this, in a perfect world, eventually this gets narrowed down to 1, which a pick random would always pick 1, which is perfect. Which means we need to set type equal to pick random. In a normal waveform collapse, we would, upon this happening, we would go and update the neighbors. But technically we don't have to, because we don't need it necessarily to propagate. We need neighbors to update. The propagation is a method for how to choose what neighbor to collapse on, but we don't realistically care. We need to know position. And then in here, we need to know the we're trying to figure out what our options are. So we need to for chunk in chunks. If chunks dot is empty, if chunks equals null or chunks is empty, then options equals types dot values. So if you create this, run options, provide no chunks at all, then you just have every option available to you. We don't want entrance. We need exactly one of these. So we do need limiters, which means we need to provide special parameters. Var, we'll call them limiters, which is a dictionary binding types to an int. Technically we could do a callable here. And so instead of just providing the entire value, we want to for type in all, we want to do if limiters dot has type, then limiters get type dot call. If true, then we can add options that push back on type. Type is being shadowed. Type. Damn it. Boom, 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 boom. All right. So we iterate through all of those. If it has a limiter, logic associated with it, we call the logic. And if it's true, then we add it. If it's false, we don't add it. If there's no limiter, then we can options.pushback type. So if there's no limiter, then we just add it. So this will add all within bounds. We need to add the logic so that types dot entrance. There's a way to do anonymous functions. Right, I can't do it in here. I will have to put a count to store types of everything outside of this chunk that gets passed into the limiters to all the chunks. It might make more sense to pass limiters into here. So it's being passed every time. So limiters. Because it's only ever needed when we call type options to update our options. That way we don't need to worry about updating a variable on this when we go to call it. So you can provide this with absolutely nothing. This will always be a dictionary, though, if you provide it with nothing, which means we can call has and get without worrying about it being null. This one we need to check for null, though. Chunk and chunk. So once we have our potential null sets, our empty set of options, the next thing we need to do is we need to iterate through all neighboring chunks and find what neighbors are where. So we can have var neighbors which we will do as a the easiest way to handle this is the cardinal directions. North, east, south. Oh, let's do this as right, up, right, down, left. We can't do that if I remember correctly because we need this to be variant. So this will get us the 4 directions. We can expand this later to add our diagonals as well if we want. We need to check inside of our chunks if position of our active minus chunk dot position technically there is a vector to I dot up. It's down, left, right, up. So we have these as constants. We're doing it as vector 2i's in all locations. And so I wonder what would happen if we found diagonals in this. It'd get skipped. Okay. So we can run, if we change this to be vector to I dot up, and we can do the subtraction, and then this will be a vector direction from our tile. So we can run, let's do var direction equals. We can do neighbors dot assign. No. Set. Direction. I want this to be the type if it's collapsed, or the array of types if it's not collapsed. So options, if, nope, options.empty. If we have options empty, and type, return type. Can I do type like that and get an array out of it? Elif options empty, but we now have no type. This returns that. That doesn't work. If I need a ternary like this, I have to do it as a full statement. Unfortunate. Let's try it again. Let's grab that and we'll do if. Options empty and type. Then type. Oh, array type. Elif so still empty, but we have no type now, because if we did have a type, it'd be here. Type. I need to know if this is greater than or equal to 0. Can I set this equal to -1? Yes, because types are technically a number internally. So this is actually 0, 1, 2, 3. So -1. So if I do greater than or equal to 0, it would mean this is defined as one of these values. Perfect. Okay. Set. Otherwise, we have no type. This is empty. So we're missing everything. So we want to set neighbors.set on direction to, what do we want to set it to here? Oh, this is empty. We actually want to set it to empty. And then our else case, where we have things, would be set it to options. This is empty, which means we can just set it to options here and make this an else instead of an else if, and remove this case. And so if it's empty, but we have a type, we don't even care that. If we have a type locked in, that means it's collapsed. We set it. If there's no type locked in, we set it to options, which will be either empty or not empty. We don't know yet. What are you complaining about? Integer used when an enum value is expected. If this is intended, cast the integer to the enum type using the as keyword. Okay, so this complains when we try and do it. This is why I want nullable, is for times like this. Because what I want here is to know whether or not this has ever been assigned. In which, I mean, I could create a collapsed chunk versus a collapsible chunk or something like that. Move the logic out of chunk into collapsible chunk, and then I can do an is expression on, is it a chunk or is it a collapsible chunk, determining whether or not it has or hasn't collapsed. Or I can define a variable in here that's a Boolean saying whether or not it has collapsed. And if it has collapsed, I know this value is set. But if I don't set this, that value is 0. That's the default value on an enum is 0. Which means it's defaulted to a hull. But I don't want a default value. So I have to make this a variant. Well, I want my type safety, so I guess I'm going to go, and I don't want to make a second class to do what this class can do internally, so collapsed. If collapsed, we take in type, otherwise we take in options. We now have neighbors defined in each direction for all options available to us, which means we can set, we can now run our logic iterating through this loop. I'm trying to think of a way to do this that doesn't require us to reiterate over these. If we start by setting all options, we could then remove. So if I have array, say var options equals that options dot remove at. I would need to know the exact position. I don't want to store it as positional is the problem. I want to change it based on the type. My thought process here is that as we iterate through the chunks, instead of storing it, we can just get the direction, relate it back, and know what items should or shouldn't be removed, which would require us, instead of all of this logic, we need to know position, or I guess direction. We need to know the direction, and then we're getting a var underscore ops. I'm going to do underscore direction here as well. Underscore ops equals this if right, chunk dot collapsed, else chunk dot options. Which means we no longer need to track all of the individual directions. Instead, we need to, as we're iterating through this, filter. And so we can then do a for opt in opts match on opt for our cases So as we iterate through this, we get a determiner on this. The one problem I'm running into on this one is if we break down our logic, must go, no, that is not necessarily true. So halls are going to be a weird one. So entrances can only have one. Exits can only have one. These are going to be exclusively determined by the limiter logic, which means I think we need to run this logic no matter what, to be honest. The first thing we need to do in every single pass is generate out options relevant to what they would be if we had nothing. And then we start trimming it back based on what we do have. And so I think this logic has to happen regardless. So we need to change this to if. Actually, let's just grab this. Return underscore ops. Right? No, we just set. Actually, we just return. If we assign it as options and then remove options later, we can just return here, which means we take this whole block, indent, and remove this. We just iterate through all options, checking the limiter to see if we've hit the limit on how many rooms we can create, or halls, or entrances, whatever. So if we ever hit this limiter, then we need to remove it as an option, otherwise it goes through. And so this assigns all of our options. If we don't have any chunks, we're done. If we do have chunks, then we parse through those, filtering down our options further. And so our logic behind exit and entrance is tied to our limiter. So we shouldn't have to worry about trimming these out. I mean, I guess I leave them in here. Removed via limiter. Removed via limiter. Because once we resolve, I just realized we don't want the full list, do we? Sorry, we don't want the full list of options from a neighbor. We only really care once they've collapsed. Yeah. So if chunk dot collapsed, else we skip it, and this is now chunk dot type, right? Type. So this will take the collapsed in each direction. If it's uncollapsed, we don't care yet. It will then process. If we ever find exits or entrances, it won't make it here because this would have already collapsed, which would mean it's failing its limiter check. There is no way for us to do anything with these. Right? No, we do need this because if the neighbor's type is that, then we need to remove. We're not removing anything. We need to make sure we need to enforce that there's a hall option in one of 4 directions of an exit and one of 4 directions of an entrance, which is the reverse of this. Because this is just give me information based on my neighbors. What can I be? So this is a negative mask. It's just removing fields. We need an alternative mask which enforces fields. I'll add it to you. I think we're gonna have to do. I think what we're gonna have to do to make this work correctly is use our A-star algorithm to try and find a path internally between our entrance and exit that we will follow. And so we do the first pass generation. If it fails, we can either regenerate, do a complete regen of it, or we could like try and force march through there, but then we get weird carvings through rooms and stuff like that. So maybe not on that one. I'll figure something out. If the neighbor is a hallway, I'm trying to think of our logic that we want to collapse on, to be honest. And with such a limiting set, we don't have any directional restrictions is the problem. I think we might have this too vague since our halls don't. I guess what we need to do at the very minimum is introduce hall vertical versus horizontal so that we can actually limit this somewhat. I don't know. I think you think on it for a second. I need to go to the bathroom. So give me just one moment. I'll be right back. So I'm thinking maybe we need to define and start from a different point where instead of using types, we use available connections or something like that, so that we can define how our chunks lay out. And so we can have, I think in the end it'd be like 9 different ways of handling it. And so we would end up with, is it, I think we still need a tile type. Is it a room or is it a hallway? No. I think realistically what we want there is a wall, door, or floor. And then we have entrance and exit as well. And then each tile can have connection points. I might need to rework our tiles a little bit on some things. But if we do wall, here, let's make this floor, which is traversable. Wall, which is not traversable. Door. This one's non-traversable. Both of these are traversable. And then we introduce var connections as a dictionary of vector 2 I, which is our 4 directions, like we were doing in here before. And a Boolean maybe, saying whether or not it can connect. This, I think, will need to be changed. In a normal algorithm for waveform collapse, this has semantical information on it that is relevant. Things like, is it a symmetrical or non-symmetrical connection point? If we only use symmetrical connection points, then this can just be a Boolean. You can either connect or you can't connect, which is, it's a wall or not a wall, right? That also means we don't actually need wall in here. Everything is technically a floor, if that's the way we're looking at it. It can either connect in all 4 directions, in which case it's in the middle of a hallway or in the middle of a room. It can connect in, 2 directions, and it's a through point, which is a hallway exclusive thing. It can connect in 1 direction, which is a dead end, so we just wouldn't have that. So I think on top of connections, we need to create connection styles, which is what I was trying to do with types. var, I don't know what I want to call it just yet. If we do let me just make this as an array while I think through this. Vector 2I dot up false. Vector 2I dot down false. Vector 2I dot left false. Vector 2i dot right. False. All right, this says you can't connect in any direction, which is not a valid option. We won't have any to where you can only connect in one direction. That's reserved for our entrance and exits. So in every other case, we would need true, true, which is a corner, or like true, true, which is a through, which is a hallway exclusive. True, true, which is the reverse corner, which is a rotation on this. And then the next set's all false here. So true, true, or true for these. This is a through, this is a corner. And then we'll have true for these two, which is the reverse corner. So this is all 2 option variants. And then we would need to repeat this task for 3 true optional variants. So 1, 2, 3, true. 1, 2, 3, true. 1, 2, 3, true. And 1, 2, 3, true. And then the last one is all of them as true. All right. So starting here, up, right, down. So it's a wall just on the left side. And then we've got wall just on the right side, wall just on the bottom, and wall just on the top, and then center. So this would be a room exclusive, I feel like. So we got a few that could go either way, room or hallway. We've got a couple that can go just hallway, and a couple that can, and then one that can go just room. Because again, this is our 3x3 chunk set. So instead of trying to determine, because this one, for example, up and right are available. Oops. Which means up and right are both available. So bottom and left are blocked off. It's a corner. That could be a hallway cornering, or it can be the bounding of a room. We don't know. This connection point on down, for example, these are available. This connection point on up could be a door. We don't know. And so instead of trying to encapsulate all of these as different ways of them to connect and everything, different ways of, or all the different variants it could be, this is all of our possible connection points. This will create paths. Given a path, I think this might be where we start. And we can just do a few different tiles on a bit mask to just get it implemented with a way we can visualize. It's either open or closed in each direction. This will give us something to march off of, at least, even if it's not in a perfect in state. But the problem I'm running into here is in a ideal world scenario, what we would do, or in a standard function for this, what we would do is we go and create a mapping of every tile we have available to us and how each direction coming out of that tile can connect to other things in any encoded information. Is a symmetrical connection, meaning a door in the middle of the wall, for example, or is it an asymmetrical, which means rotation matters, which means it needs to connect on the top or the bottom or, you know, whatever. So we would go through and do that for every single tile. Then, given connections on the next point, we would say, you know, this needs to connect in, remove things that can't connect to it. Every time we collapse, we would check its neighbors and re-roll what is available now based on neighbors, which says what it could turn into, but it doesn't say what it has to turn into. Not quite. What I'm trying to figure out is how I want to introduce, or how I want to work through this waveform collapse function, so I can do procedural generation, because I have the tiles implemented already in tile sets, and these are available shareable tile sets, but I have it inside of here. So all I need to do is reuse these to paint. So I can paint tiles already, and then we can call this to bake those tiles. What I need to figure out is how do we map the tiles so that they trigger correctly with everything. On the waveform collapse. So I want it to be like, what I want it to do is I want it to effectively have a start point. So if I go to floor layer, have a start point, it will then march around and create, you know, some sort of path that would, you know, let's do a cross and then down and then across and then, you know, down. And then we have some sort of exit that it's getting to. And then from that, we would then define, well, this is a room, this is a room. Oops. You know, something like that. And then here's where this room connects, here's where this room connects, so on and so forth. And so that we would end up with all of the different ways we connect things. That's what I'm shooting for right now. In order to do this with the waveform collapse, I need to define what each of these partial segments looks like and how they relate to one another. So that I can start with this saying boom, entrance, boom, exit. Figure out how you link the two in between. The problem I'm having is waveform collapse functions are realistically designed for start point and then just branch out, not really this create a path to an objective style. So a more realistic way of handling this would be, I probably shouldn't be using waveform collapse. I should be setting start point, minimum distance, end point, drawing some line between them creatively, and then using waveform collapse to branch off of that afterwards. Is what's going through my head right now. I don't realistically care. It would be a little weird if, let's say, exit wasn't here, exit was up here, for example. If this over here was our exit up in the corner. If this is our exit, I don't really care if this branches out like this, and that's how we get to the exit. It's a little awkward going through a room and not particularly realistic. But it is an option. What I was in my mind, what I was trying to think of ways to do is prevent this, which would require me to have a defined path ahead of time. If I get rid of that as an option and I say, I don't care if it goes through a room, my waveform collapse function becomes a lot easier, to be honest, because now I just need to know what connections each of these tiles have, and then I can figure it out later of, you know, oh, this is a hallway based on how it's linked together. Oh, this is a room because rooms are contained like this. We end up in weird situations with, like, this becomes a possibility where you take a hallway into a room into a hallway, because we've defined hallways are one wide, rooms are more than one. And we also get weird little things like this is now a room with 2 exits. I think I'm okay with that. We could do a pass later that would try to step back some things, I guess. And so we can paint a lot more. Right now, because I've never implemented a procedural generation algorithm for a game on how to create tiles. So the most important thing for me now is figuring out a way to get it to generate something useful that I can visualize. Because then once I have it rendering and doing the bare minimum, I can enhance it. So for now, it's I need something functional, and then we will work on polishing it up later, is kind of what I had in mind. So that's kind of where I'm working from in the current state of things. I think this is probably the best way to go about it. Is every tile can connect in different ways, like we defined here. These are all the possible connections coming out of a tile. And instead of the normal way of handling this, where we say, here's our tiles and the ways they can connect, I go the reverse of it and say, here's all the different ways tiles can connect. And then I print something out, making it transition across my environment. Then on my next pass, I resolve back saying, oh, well, this is when we carved this out, we defined a hallway. When we carved this out, we defined a room. And so then I can take each of those 3x3 chunks that I've carved out, or I guess 5x5 is what I'm using. I can take each of those 5x5 chunks I've carved out, give it context, and then use a separate waveform collapse function to then carve out each tile within the 5x5. And so for now, I want this, and we're ignoring size, so I can get a view of how things will look. Then my next step would be define semantics on top of this, and we render that out. So I can define, oh, this is a hall, this is a room, yada yada. And that will give us the contextual on what it should look like. Then the next step after that would be factor in size to carve it based on that contextual information. Then we would have to do another iteration that introduces the allocation of enemies and pickups and power-ups and those kinds of things. And so we're just going to do multiple iterations, each one refining the last iteration. And so this first iteration is what I'm working on now. And I think I should just go this route. Instead of trying to define types early on, I'm just trying to define how do the chunks connect together. I think there might be one pass that happens before this on a minimum chunk distance in allocation between an entrance and exit. I could also run waveform collapse functions in 2 separate threads coming from either point, and eventually having them resolve at some point in the center. If I give it a concrete defined space as well. I'm worried about dead ends is what I'm worried about right now. What I don't want is for it to try and generate a start point and then hit a dead end. You can never reach the end point. So maybe I should define a separate algorithm that's just a pure marching algorithm. And along that marching algorithm, I can set options for each chunk along that algorithm to where it filters this down to chunks that align with the marching. So it's guaranteed a path. And then instead of just using the singular start position as the beginning of my waveform that goes into this, or just the start and just the end, my start would actually be a fully qualified path from start to finish. Maybe that's what I should do instead of trying to go through this whole chunk thing. Because that would guarantee a viable solution, which is one of the biggest hurdles in these kinds of procedurally generated algorithms when you have to have an exit. Like you have an objective on the map that you have to be able to get to. I can either generate something and then place things randomly throughout the world and carve paths through it, or I can write a simple algorithm whose entire purpose is to connect the start and end in creative ways. And so I would just take this blocking that I'm doing and take it one larger step up. That is, instead of it being, an iteration where it goes into a full map, into 5x5 chunks, into 1x1 tiles, I would have an even higher level one that would give me start and end points in iteration or something. And so I need to resolve a series of these with start and end points with goals between them. Maybe? No. I'll have to think about that one. I think sitting in a 5x5 that I need to waveform collapse another layer later and add enemies and objectives and POIs and things like that to it, I think is fine. I think the main problem is I need that initial marching to ensure we have correct paths to any and all objectives. So maybe I create a bounding area on the first pass. So when we do our map generation, the first thing it needs to do is define something like start point is 0, 0 every time. So we can add a vector 2i. This should be a vector 2i. And this should be a vector 2i. And this should be a vector 2i. Oops. It should be, I think I can just do player start into a chunk.new. So now we have our first chunk. We would need to define this. Is there a way to do constructors in GD script? GD script constructor. Static function create. Let's pull this up. Init. Okay. So we can do chunk. We can do boom. Init. And we can take in a if we do this as position vector to I, do they allow for do they have what's the word I'm looking for? Like in C++, we'd be able to do, instead of defining in there, we could define position as a, position to position or something like that. And it would auto set innates for us as part of the constructor, but I don't think they have anything like that. There's a word for it. I'm blanking on what it's called. I'm not seeing anything on it on constructors, unfortunately. We can set default values. Yeah, all these examples are using stuff like position equals underscore position. There is a way in like C++ to collapse this down, and so you don't need to do this, but I couldn't see anything in here for how to handle that on GDScript, so we're gonna go without it. So we would take in a position, which will define our position. We are no longer using this type, so let's comment that out. Now I want to walk back the changes we did through here. Okay, and then we need to know whether or not it's collapsed. But we could theoretically do that through definitions in connections now. Since this is a dictionary, it means it's nullable. Well, not necessarily nullable. We don't care if it's null or not. We care if it's empty or not. So we can check to see if it's empty, which would handle how we determine whether or not we've collapsed the cell. And so we would then define connections as, here, let's grab this. Do that. Pop in an underscore here so that we can do connections equals underscore connections, which will handle what directions we can connect on this. And so we can march through and get position and connections as we go. And when we define our initialization, we can say in here, this is taking in a we need to know position within the chunk just so we can determine connection directions. So if we trim out directionality from as just a storage in each direction, we don't need position in here anymore either. Which means we can define it here purely through the key. And then we can set the vector to I. Actually, we should do oops. I do want that though. We'll set connections. Let's change this to a dictionary type. I'm not going to define a concrete type on this because I can't, because I'm about to nest a key. But let's set this to we're going to do connection map connections, where connections is this was up and right are available. So corner. Is that how I want to write this? Corner. Technically, I could bit mask this. Can I do GD script bitwise operators? Support standard bitwise operators. Okay, so we have the bit shift that we need. That's not what I want. Where is? I guess I could do it that way. I could just do it through a mask. Okay. Does it have a byte type? Right, I don't need to set it as a type. I can just technically just do it as an integer, which would probably be the best. So if I did this is gonna be weird. This is gonna be real weird. Let's comment this out. I could technically do connections as an array of masks where we define, I don't even need to do it as an array of masks. Our connection can literally be 0. If we do top, right, bottom, left, I'm going off of these cardinal directions in that specific order because we run, I'm very used to HTML, CSS, and so we do top, right, bottom, left. That's how it propagates on margin and everything. So I'm just going to stick with that. So if we do top, right, bottom, left, that would give us these 3 as open, and then that is our blocked. Do I want it in this direction, or do I want the inverse of this? Because technically, least significant bit is what we're going to be processing on. And so if we were to loop through this, processing the least significant bit each time, we would get, it'd be left, bottom, right, top as we process this. So yeah, I want to invert this. So now as we process this, it'd be top, right, bottom, left, using bit shifts to process least significant bit each time. So that would give us the directional mask. And then we can say vector 2, we need a minimum distance between these two values for player start, player end. And so we can create, let's call it export var run length. You know what we should do? We should take this and we should do that. And then we should put this inside of the ready. We're going to do chunks dot set vector 2i, vector 2i. All right. Dictionary. cannot pass. Oh, that's right. I needed to update this to use a bit mask. Let's just store it as an int. That's fine. And connections will just be an int. So now when we go through and process this, we can get the directionality off of it via a bit mask, which will save a whole bunch of memory and should increase our computation times fairly significantly, because we just need to compare whether the bit in that position is the same. And we can do that simply through a mask. Because if we do, the reason that this is relevant, if we wanted to know something like func can connect, we take in a bit mask as an int, and we return a Boolean. And then we are storing our bit mask as connections internally. So now all we need to do is connections and bit mask as a bitwise operation. And every location where, if we were to replace this with, let's say, again, reverse, we just get this as an entrance. This is our entrance value, which has a left of 0. Because remember, we do right to left processing, and then it is going to be top, right, bottom, left. If we were to take in a hallway that is a through hallway, which means you can go left and right only, which means top and bottom are going to be 0s. Well, going reverse, we can go left, bottom, right, top. So this is a standard through hallway. This is an entrance, which means we can go any direction but out. We cannot go back to the previous stage. We just need to know, can these two connect? Is there any overlap between these two that can connect? Yes. When we and these together, we can get the directionalities from these. But because this would result in a 0, 0, 1, 0. This is in fact greater than 0, which means at least one of these matched. However, this is given a mask coming in, which is what we're providing here. Given a mask coming in, does it match on sides? Technically, we need to invert this. So we can, and it's been a while since I've done something like this. 1, 0, 1, 0. And we want to transform this into 0, 1, 0, 1. Because we want to invert all of them. No, that's not correct. We need the, so realistically what we're checking here, let's say we want to know, can we go to the right? Anything about how we want to handle this within a chunk relating to another chunk? Testing the directions is fairly straightforward. Like, if we wanted to know, can left, for example, then what we need to do is we need to take our bit mask coming in, ampersand it with left, and then this will result in a 0. We can't go left. A can right would be a bit mask with 1 on, because again, we do, right, top, right, bottom left, which would result in 0, 0, 1, 0. Because again, when we and these, right, we need to do the bitwise and, which is that, right? What's the bitwise operator for Yeah, it's and instead of the double ampersand with this Boolean, we need the single ampersand. But this bitwise operation will result in, if both of these are 1, it gives us a 1. Everything else becomes a 0. And so if this is greater than 0, we're good. You know what I mean? And so this means if we're checking to see if this tile mask can connect on the right side, then we're good. What we need to know is, can connect is taking in a chunk of type chunk. And we need to know, given our options, we would want to, for, dir in directions, where directions is, a range of possible options or something like that. Range, it's what we'd want to do. Something like that. We would want to, as we iterate through this, we're going to want to do a progressive bit shift. So, position. I'll just call it mask equals connections, something along those lines. Because connections is our bit mask. We can set mask as a, yo, what's up, Frio? We can set mask as a bitwise bit shift. So if we wanted to get the first entry, we would want to shift by a specific amount, being 0. And so we would want, rightmost is top. And then we'd change this to 3. And then we would do the mask on each of these after that. But we need to check top on ours means, does it relate? How does it relate to bottom on the opposing tile? Because we need to know if we've got a tile up top and a tile here, and we need to know if these two can connect. What we really care about is the top bit, which is bit 1 on our bit mask for our current tile, and the bottom bit, which is bit, or the bottom mask, which is bit 3, right to left on this tile. And so if we do a shift 2, when we do a left shift, shifts the bits of the left operand to the left by the number of positions specified. So we can give it a full number of positions. Because if our mask is, again, we do it inverse. So right, bottom, left, top. And we need to know, can the top on this one, how does that relate to the right, bottom, left, top on the other one? But we really need to know is match this and this. And we need to know if they're both that. Which means a shift, a right shift of 2. Because we're looking at position 0, 1, 2. We're looking at position 2. So given a chunk and a position, which is an int, we'll call it position offset. So if we offset this by, if we and these together, after doing a bit shift by position offset, this would result in again, if we had position offset of 2 in this case, we'll say this is equal to 2, then the result would be 0, 0, right bottom. And again, we really care about top here. So now we can just and these two together and it will give us, because, you know, if our mask is that top bit and then our bottom bit has been shifted in now, then we can AND those together. And all we care about is this bit. Technically, we have RBL. So if we were to AND these, it would also be interesting matching on the right and left as well. So maybe we want to not only technically I can find that if we do, instead of position offset, if we provide a bit mask and we expect our bit mask to be like, again, we are interested in the top on this one. I'm trying to figure out a way we can do this without having to know the exact context, because if we're looking at top, we need to look at bottom on this one. And so a way to incorporate this so we're not having to do a specific bit shift, then some sort of mask, and then, because this bit mask would need to be 0001. Granted, this is a concrete mask every time. So if we go back to what we were doing here, position offset, all we need to do is take the result of this and ampersand that, and it will remove everything that's not this one bit at the end. Or sorry, that we're doing the check on. And so when we run this, it doesn't matter what these values are. It only matters what this very end value is. And so all we need to know is the offset on this chunk to relate it to the one position. That does also mean we need to know. So if we RBLT, we need to line up top and bottom. A bit shift of 2 will put bottom here and right here, which aligns those. If we were to loop this, it would mean top would be here and left would be here. So if we do a 4-bit positional shift by 2 and then cause it to wrap, how would we handle? Okay, so if we have an 8-bit instead of a 4-bit, and we wanted to do ordering doesn't matter. So top right, do O, and then right, and then it's going to be bottom right. So we'll do I, and then bottom, and then bottom left. I can't do O again. Can't do T. So M, and then left, and then top left. So E. If I were to duplicate this, and we're trying to mask against these, I need to know when top matches to bottom, which means if I bit shift by 3, no, that's backwards. I want to know when top left, which is what this E is. Hey, let's just do it this way. T, R, R, B, B, L, L. That's a little bit easier. So the second T. Yeah, I'm trying to do a waveform collapse, essentially. And so I need to know with a mask, how given a tile's definition on the different ways it can connect, if it resolves a segment, so if it resolves like, this tile here, you can find my cursor, this tile here, if it resolves this one, I need to know how can its neighbors connect to it, so I know how the neighbors should be resolved. And that's what we're trying to do right now. And so if I do this alignment, I need to know top and bottom need to align. Which means that in order to do that, I need to shift like this. So now top is aligned to bottom. So those are aligned. And then I was going around the loop as I was doing this. So the small b should be bottom left, which would link to top right, which is true. So I need to offset by half the length, because the next one would be right to left, and then this should be an R. So it would be right. So this would be bottom right to top left, which is the next linking, which would rotate into top to bottom. Yeah, so this is always opposite. So all I need to do is know if we're bit shifting, how much we're bit shifting by, which is based on the mask details that we're using. And so if I wanted to do, I could do an 8-bit. Instead of defining 4 cardinal directions as, let's assume that you can go in all 4 cardinal directions. Instead of defining it as, 1, 2, 3, 4, we define it as this. And this would be a block that can only go in the 4 cardinal directions. If we did this, which means we're using a full byte, 8 bits every time, to govern all 4 possible directions that you could connect to this tile. We know in this code that we need to bit shift by 4, then cycle. So we would mask. So if we take, this is a weird one. If we take a var offset, again, let's assume this is our mask coming in. Let's do mask. So if our offset equals mask ampersand 1, 2, 3, 4, 1, 2, nope. Don't want the beginning or end. 1, 2, 3, 4, 1, 2, 3, 4. This will get just the second half of our initial value that came in. Now we can take mask and bit shift by 4, which is half of our byte, 4 bits. Can we? I don't think we can assign in. So mask equals. We can now set offset. Actually, we can do this all in one. So we take the rightmost 4, and then shift it to the left. So these 4 from our mask are now in these 4 positions. And then we take our mask and we shift it to the right, which is the inverse of that. We take these 4 on the mask and shift them over into these 4 positions. Then we can set mask equals mask or offset. And now we'll merge those 2 back together. And so this new mask is now rotated like this was by 4 bits, which means if we ever want to and again, this mask is coming in, this would be mask. Let's do that. So we've rotated around the central point of our byte, taking in a mask, and now well, I guess this I probably shouldn't be updating this since I'm providing it in just to be safe. Let's just set var mask equals mask. Let's do that the other way. Mask equals underscore mask. That way we don't update the value that's being passed in, just in case. We take this in, we rotate it around the central point so that we have the alignment that when we AND these together, we know which section is functional. Now we just need to know the direction. So are we trying to create a I shouldn't call this mask. I should call this con. Let's do that. We also need a mask, which should be relevant to, or sorry, should be in terms of the connection side we want to know about on this chunk. And so if we want to know, can this chunk connect on, again, we do top, so can it connect on the right side? 0, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. I want to know, are they viable to connect on the right side in relation to this chunk? Well, if we just take, what do we call it in here? Connections and return. Connections and our connection as it is has been shifted, and mask greater than 0. We've masked it down to a single bit coming through. So once it hits this point, it just needs to know, is this value a 1 or a 0? And now, just by knowing the connections of a tile coming in and what side of our original tile, we can determine whether or not they can connect. So let's change this to chunk. And chunks have a chunk dot connections. We technically could store this as a enum as well. We can do sides. Yeah. Top. Okay, so this is gonna be an issue. These are all meant to be bits. I need to turn those into integers. What kind of bit operation stuff do we have in here? Because I don't think we can do GD script byte. I don't think we have a packed byte array. It's not what we're looking for though. Let's do, I mean, technically what this is we would do 1, 2, 4, 8, 16, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this is 2 to the 8th. And then if we wanted top right, it would be 2 to the 7th, right? Because it'd be top left. So this is our 1 position, right? So this is our final position. Top was meant to be our 1 position. 1. And so top right would be 2 to the 1st, which is 2. 1, 2. And then next up would be 4. Okay, so, and then we would do right equals 2 to the 2nd. And then bottom right equals 2 to the 3rd. And then bottom equals 2 to the 4th. And then bottom left equals 2 to the 5th. And then left equals 2 to the 6th. And top left is 2 to the 7th. So now we can use an enum to get a numerical value for every one of our sides as a bit mask. And so we can say side coming in from sides. So given a chunk and a side, where side is used as an integer value there, we can now filter. So given a current chunk and a goal chunk, we can know whether or not you can connect. And then the default connections would assume you can connect on all sides, maybe? Because it hasn't been filtered down. And then we can just we can, if we ever need to know, when we need to mask to remove values, we can XOR a side into your connection set, and it will mask out that side. So by default, we can assume, I don't think there's a value for that. Whatever. We can do 2 to the 8th minus 1. I want to say this is a problem. Let me check something real quick. On ready. Let me do, right. What are we doing with init bit? Oof. Let's just print connections at this point, and then we can go through with that. Five. Well, 5 is not right. What if I do 2 to the 7th? Four. Oh. This is not the mathematical power operator. this is the XOR operator. So it's doing an XOR operation on this. Whoops. GD script math power function. Let me see if there's a nice POW. Okay, base exponential. Perfect. 1. We'll just do 2. POW 2, 2. Is there a POW int? Ooh. Here, we'll just do this. 4, 8, 16, 32, 64. Oh, that's not 6. 64, 128. This is going to be 255. This is 1s across the board in every possible section. And so we no longer need this, right? We can just define it as connection available on all sides. Actually, let's add it, and let's just change this to be colon equals 255. And then if you provide it, we'll set it. So you can give us your side mask if you want to. But you don't have to. It'll, by default, you connect on all sides, and then we trim it down as we go. And then we can connect will allow us to, given a side, know if this chunk can connect to another chunk or not. This is going to be a very useful helper function later. Then we will add another helper function that is remove side. And it will take in a side, return nothing, and it will just update connections based on the XOR assignment of side. As it's an XOR, and our sides are essentially bit masks, which only have 1 bit enabled. It will be a 0 if it was previously a 0 in the connections. It will, at the sides 1 bit location, it will be a 0 if it's currently 1 at the connection location. Right? No. It'll be 1 at that location always, unless they're both 1. That's not what we want. We want to invert our side. Okay. I'm worried about using not, just because I don't know how many bits are going to be in one of these integers. I guess I could be assigning this exclusively as uint 8, right? Uint 8. Is that not a thing? GD script uint 8. Not a thing in Godot. Does not have a dedicated uint 8 data type for individual variables. The built-in int type is a signed 64-bit integer. Okay. So Redmain's asking, I want to ask you a question to see how you will do it in C# because I want to see how you will think about it if you have a constructor for a class and I will pass it to print the name and the parameters. How can I get it from user input and pass this value I will get from user through a text field on the UI and pass it as the argument? So think about it as a constructor for a class, and I'll pass it to print the name and the parameters. So you're trying to, upon creation of the class, pull a value from a parameter? Are we talking something like this, where you're getting a value in as part of your constructor? Or are you talking something like, you know, in your constructor? Oh, I can't on this one. In your constructor, grab like a label or something and .text. So you're asking how to create an object with that? Like you already have the value from the input, you just need to figure out how to pass it into your constructor? I mean, it's times like that when it's syntactical things that I would look it up, but be concise on what you're looking up. And so, like I have, you know, this pulled up over here. I'm not looking up how to do the thing. Instead, I'm saying, like, this is the thing I want to do. Does it exist? And so it's really a problem with scoping your question more so than anything. So if you have what you need to know is, given a field, let me find here, because I'm doing something similar. Not quite what you're asking for, but the field lookup stuff I am doing. I'm actually doing the inverse of it in my game menu scene. So in my script for this, I have a few locations where I'll go through and I will do group visibility. That's not what I'm looking for. Settings. I think I do it in here. Show settings. Here we go. Subtitle. So if we look at how I do my setter in here, I'm doing the inverse of what you're saying. Instead of getting the value, I'm assigning the value. So let's say you create a character for an online game. I want to take the name you enter and then print what you entered. Welcome to... Yeah. So what you would do is, instead of... So I have, you know, run... These are my listeners for when you press buttons. And to show you what I'm talking about here, it's the menu. So when you press buttons, specifically what we're looking at is the link for settings, which triggers this subtitle label, which is a subtitle. So I have the primary title, which we're seeing here. This is my primary title, is the Psychocats. When you click settings, it creates a secondary title. I don't have any buttons on the settings page aside from cancel and confirm right now, because I don't know what all settings I want to implement yet, but that'll go in between. And so what it's doing is, it's on click, it sets this variable. It sets this variable. I use a setter. And so that would be the exact same as if I copy pasted this down there and just use the value directly. But I'm doing an assignment. You would do the inverse of this. And so if you wanted to print it out, you'd do something like, you know, my object in Godot is .new, and then I would take in the value as it exists now and pass it to my constructor. Predefined, not dynamic, as in I know what my input fields are. In your case, you should also know the alternative to this, if you're not using concrete objects like this, would be that you are using some sort of for I on, you probably have on like fields where you're going through and generating your fields. A text that you want to label. Well, in your case, you wouldn't be using a label. Instead of a label, you would be using some sort of input. I think they call it text. So you'd be using like text edit, for example. And so instead of referencing the text, the label here, you would do like, you know, name text field would be your reference. And then you would grab this on it. Well, I guess to be more accurate, name text field. And so you would create your object with the current text value from that input when they triggered submit. If you didn't want to do it on submit, they're going to have hooks, text. They call it text edit here. So text edit, whatever you put in here is your text value. And whenever it gets updated by the user, it gets updated too. But there's going to be a hook in here that is text changed. And so you just connect to this, and every time text changed, your function you tied to that would update. So if we just link that in here, every time this text field updates, we can print out the field.text. And so now, if we restart this, and we go to, oh, hang on. I have a weird structure in here. So let me just tie this into my current structure. Let's put it below settings above quit. And we are going to give it a group of main menu. So it shows up on the main menu. I should add will that fix the sizing? No, I need to add a minimum height on it. If we layout custom minimum on our Y of 20 pixels, sure. Hey, that way it's a little bit easier to see in here. I probably should have done a little bit better. But if we do, all right, what I trigger our error on? Invalid access to property or key text. It's not called text. Oh, sorry. I moved my file structure. Now, as we type, you can see it printing out onto our screen. And so every time I do this, I could pass it to something. If I wanted it to be on submit, I just need to use the button listener for one of my buttons instead. As for how I got this path, I added an input. I don't know how Unity handles their structure. It most likely has something similar to this, though. But if you are creating your form dynamically, you would just store it as, you know, var text field equals, and then you would text edit dot new. Create your node and just store it. And then you later on, you'd have your form.add child or whatever the equivalent is, and then add your field. And now you can also do text field.connect on whatever your event listener is. So in our case, it was text changed, I think. And then we add our, you know, callback function, you know, text updated. And so we just add this, and now we've dynamically added that runtime. If you wanted this to be based on like a form structure where you have a dictionary, you can iterate through keys on a dictionary and add them. And you just need to know like field names. Let's call it name. And it's a text edit type. And now you can just iterate through here on all the values calling new, stuff like that. So if you were doing it dynamically, you would just need to add a connection on the event trigger. And then this function would handle calling back and stuff like that. Did that answer your question? I can't say for certain what the exact syntax would be in Unity. But that's how I'd do it in Godot. All right, let's pop back into here. So in our chunk logic, we don't want to XOR with this. We want to invert our mask. So let's not and 1, 2, nope, 1, 2, 3, 4, 5, 6, 7, 8. We want this to be a bit, 255. Because this is coming in as an int. And so 255, which is our connection basis. So we will run this operation and then XOR here. And so what this is doing is it's taking our side value, which we can grab one of the sides up here. Let's go with right. So we would have a side value coming in of, so a value of 4. Because this would be 1, this one's 2, this one's 4. So this is our right side coming in, which is a value of 4. We then run it through the not operation, which is going to give us the inverse of this. But we don't know, it's like 64 bits. So there's a whole bunch of ones because they were all zeros before. And then a 0, 1, 1. What we don't want is all of these extras. And so we will take this and we will AND it with a bit mask that has a whole bunch of zeros, however many bits are in the amount of bytes we can allocate. And then 1, 2, 3, 4, 5, 6, 7, 8. And then our 8 bits all set to 1. And what this is going to do is when we AND these together, it's going to filter out all of our zeros from this. And so we end up with just these 4, 5, 6, 7, 8, just these. And then everything before this is now a bunch of zeros, so we can ignore them. And so we've taken our 7 zeros with a 1 and position 3 to 7 ones with a 0 in position 3. So we've completely inverted our intake, is what this line did. Now we can run an XOR. And so if our connection set is 2, 3, 4, 5, 6, 7, 8, our default value, and we run an XOR operation with our mask coming in, which again, remember this was the right side inverted, then our resulting value is going to be our input, because it's all ones, except this will be a 0. If we were then to do this again to remove the left side, instead of a 0 here, we would be doing the equivalent of so this is top right, right, bottom right, bottom left, left. So we're going to be taking this as our initial input, because again, we want to remove the left side. Then we will run it through our inversion, which will be 1, 0, 3, 4, 5, 6, 7, 8. That's this operation we did before. And then we would have a resulting value. Again, if we were to run this once to remove the right side and then run it again trying to remove the left side, we would then run these two together. The 0 would stick because it's a 0 or 1, which is a 0. Or sorry, an XOR. We're not trying to XOR here. We're trying to AND. That's right. Our XOR was above. we inverted it so we're in a mask. We're not trying to XOR, we're trying to AND here. So that 0 and 1 results in 0. 1 and 1 results in 1. And so the place where we have a 0 here and the place where we have a 0 here will get combined into our output. And so we can take this and our resulting value would be a 0 at this position. And so now our new thing says we can have top right, we skip right, and then bottom right, bottom left, we skip left, and then top left. That's our mask, is what we're going to be working off of. And we've defined all of these masks as enums to make life easier. And so we need to update this so it's an AN. But our goal here is we not on this, mask it down. So we mask it down to just the 8-bit, giving a resulting value. And then we AND that with the current connections we have and then assign it back to connections. That's what this AND will, perform the bitwise and then assign, assuming that is a valid thing in GD script. GD script ampersand equals. Bitwise and assignment operator. So this will remove one side from possible connections on this instance of a chunk. Okay, so we've redefined this to handle propagation. So it can, when a chunk updates, it can remove all possibilities from its neighbors. When we collapse it, we don't have a way still of determining collapsed state though, because we are no longer, we've inverted our connections. So it's remaining potential connections, not our locked in connections. So until collapsed is called, so until we've collapsed, we can assume that this is malleable. Once it collapses, though, we need to lock our connections. So we cannot remove side. So if collapsed, return. So once we collapse, we can no longer update our connections. This just doesn't actually perform any updates. It just informs us of whether or not it is a viable update. So we don't need to prevent that from collapsing. I'm going to go ahead and remove this. And so now we have viable options that would come through. So if we trim out some of these values to clean things up, we no longer need position. We are still going to deal with size, but it's going to be a thing to do later. All right, now we can trim down connections and then we can lock a connection state. So we need to provide a function to collapse. Void collapsed equals true. We need to know to do choose among viable options. I think the thought process I'm going through right now is that when you call collapse, it would analyze all possible connection types and then resolve down to a singular connection type. And right now, we are running a right now I'm trying to think how to handle this one, because effectively when we first generate, everything is an option in every direction, and then we're trying to restrict it back. Maybe I should be going the opposite direction with this, and we should be increasing. So instead of removing sides, we should be adding side options. It's pretty normal here. I think what we should do is our default should be 0. And then we can remove side options, and we can add side options. Which will take in a side. And then it will, if collapsed, return. Else connections. And no, or. So given a side, we will add it to our connection mask to let us know whether or not that, or to just add it to it. And so by default, we start with no connection options. And also we should probably go ahead and set collapsed. That way, if you want to provide a predetermined collapsed chunk in, you can. That's what I'm doing here, by the way. So you can initialize a collapsed chunk into your map, which is what we're going to be using for like entrances and stuff. And you can define these are the available connections. It's collapsed, so you cannot modify it. Use it as a basis point and move on. For all others, you can add side, remove side. And so the add side is I've waveform collapsed. I've got an empty node next to it. Add all sides to it. That I should probably do this as no. I'm tempted to say that we provide an option to do multiple. Because if we and together, or together sides, because if we wanted to call this, if we wanted to call add sides, we could say sides dot left, or sides dot right, or sides dot, bottom. Did I call it bottom or? I did call it bottom. That's a habit. This would OR these together, and so they would get a combined mask coming out of it. And then this function would work the exact same way. We just need to allow this to be an int instead. So if we say int, we could do sides. And then remove sides, which would allow us to do multiple at once, which is again an int. And so this would allow us to take in a when we're creating a new node, it defaults with no connections. When a neighbor collapses, when a node collapses, it would grab its neighbors and call with its side mask inverted. So we need a way to can connect. So we want to do this operation, I think. So if we provide this as a helper function of requested sides, for example, no. realistically, what we're doing when we establish a node in our array, so let's assume we have like a, zeros being undefined nodes and ones being defined nodes in an array, like a 2D array. We have something initially that looks like this. And then we say, this is our starting node. Or sorry, let's say this is our starting node. Boom. We now need to define in all three of these what can be available. So we look at this mask and we say, top, not an option. So when we collapse this, it needs to take in a mask that looks something like, it's at the top. It can't go up anymore. It can't go left anymore. So not top, not top. So these are our sides, not top right, not top left. Additionally, it can't be left. It can't be, it can't be left, bottom left. We've defined here in this node saying it can't be bottom, so not bottom. So we've ruled out all three top options, all three left options, and the bottom option. So it can either go right or it can go down as its connection options. And so we negate all of these when we create it as the mask. And that's defined by, a bunch of these were defined by it being on the edge bounds, which in our algorithm we're not going to be doing, except for we probably want to eliminate this one. So it's not looping back behind an entrance, for example. So what we might have to do is waveform collapse these as collapsed nodes with 0 values when we create our entrance point. And so our initial node, our start node, would automatically, instead of injecting 1, we inject 4, with this as being viable for these option directions that you would expect. And then the options that we don't want are immediately blocked off with collapsed all zeros on masks, so nothing can connect to them. I think that's how we'll handle that. So we then have all options coming through that collapse back. This would get generated because this one collapsed. It would then want to look at all neighbors to determine what its mask should be. Once it's initially created, it no longer cares until neighbors update. And that's when a neighbor updates, that's when it would go in and remove sides. So this is a neighbor updating, saying, if it was previously an available side, do nothing. If it's no longer an available side, remove it. Like, these two should be able to connect. This guy collapses, they need to be able to connect, kind of thing. Trying to think of a way to handle that as we propagate out. Man, rendering these out is going to be difficult. I think what we're going to do is mask resolve on our as a switch on our connections. And so we'll just do some clustered ones for now and just say, it's either one of our 4 cardinal directions or not, you know what I mean? It might be how we handle that for now. I'm struggling with it because I'm trying to resolve back how I want it to work versus how the waveform collapse is normally handled. In a normal scenario, we aren't doing this. We aren't creating our connections as we go. We are given a list of, like, masks that it could possibly be, and then we just choose from the list of potential masks. I'm trying to construct masks as we step through this. That's why I'm struggling with this so much, because an easy one would just be drop in a set of tiles, create 4 corners as bit masks, and then they can link or they can't link, you know? It would be a lot easier to do that. A lot less expressive, though. And I want this algorithm to be fairly expressive because I want the... We're trying to create a stealth-based roguelike. So we need the rooms to be generated under pretty solid walking, like pathing algorithms on how we connect everything. Almost to the point where I'm tempted to scrap this and go with a different algorithm completely that utilizes pre-built rooms, just so we don't have to run in. Because what I'm concerned about is it's not a big deal for us to ensure there's a path that you can follow. And if this was combat oriented, we add rooms across it and just dump any enemies in there, and we can gate access moving between rooms fairly easily based on enemies that were generated. Unfortunately, we don't have death triggers because this is a stealth-based game with no combat. Normally, this would be a puzzle game. And so now we're trying to figure out a way to procedurally generate interesting puzzles, is realistically what we're building. And so I really want it to be good and expressive on that front, because procedurally generated puzzles can go wrong real easy, and I don't want that. So we need to figure out a way to handle that is not going to get repetitive, which is why I want to avoid recreating the same room or just using a handful of self-created rooms or manually handcrafted rooms that just get mixed together, because those will get repetitive quick. That's why I want to do procedural generation, because I want that roguelike infinite runner feel. Not quite infinite, you know what I mean? Like, can keep going at the end, getting harder and harder. But I need it to be solvable. I need it to be interesting. And we need them to have set sizes and lengths is what we're... So Masudi's saying it cannot be completely procedurally generated. It needs to work off of some guidelines later on, like a set of rules or some algorithm that each generation consults, right? That is what procedurally generated means. So what you're thinking is, like, so in games, there's kind of two main ways, and one's referred to as random generation and one is procedural generation. Random generation is realistically, it's what it really boils down to in practice is handcrafting some levels, randomly choosing those, and then linking them together. Procedural generation is stepping through and following a set of guidelines. How many passes you do and stuff like that. So what I mean by that is each step that you take in your generation has to follow bounding rules. And so the waveform collapse function follows that. And so the rules can be things like halls can only be next to halls. That can be a rule in your procedural generation. Or, you know, rooms must connect to at least one hall. And these rules that we build off of we can add and change over time and do whatever we want on that front to make this better and better. But we can also do procedural generation of the map, but also how we place things within the map. Sorry. Which means that we can govern how many exits should exist as a rule in our procedural generation. We can govern all kinds of things. Yeah, so I can use Perlin noise to generate this. The problem with Perlin noise is while it's got smoothed edges and things like that, it's not really, there's no guiding patterns. It's meant to be random by nature. And so you can tweak the numbers to give continuous paths and stuff, but which is good for things like cave formations and stuff where you want random that you then augment. We don't really want randomness. We want a fairly rigid structure to follow, which is why I'm trying to do this as a waveform collapse function, because we don't want it to just randomly choose tiles and build paths. We could probably do that to get a way to connect our start and end points, to be honest. We could run a Perlin noise with a threshold until we get a continuous path between the two, then clear everything that's not that continuous path, and then use that as a basis that we can then crawl out from, to be honest. That would be an option if we started mixing those. I was thinking we just use a step function for crafting our initial haul path between the two. I probably should do that first. That would solve a lot of these problems. Just get a way to render chunks on the screen and get it to just carve a path between the two. Maybe that's what we should do. So if I go back to, hang on, dog's ready to go outside, so it might be time to wrap up the stream. Yeah, it's already 4 o'clock. So let's go back here and I'll do to do. Step 1. Give start and end points. With level driven distance apart on X. Randomize Y for exit within X. All right, and then let's do this. Boom. Step 2 from this would be carve a path between entrance and exit. Collapse. So this will give us the I don't know what we want to use on this algorithm. Possibly via Perlin noise for curving paths. An alternative to this could use waveform collapse with rules on max distance per straight run, when/how frequently to corner. So we can actually create a custom waveform collapse function that will handle our stepping here if we wanted to make this to where hallways are more straight linear things that can then branch, square, do things like that. Step 3, collapse path in broader waveform collapse algorithm to resolve what's the word I'm looking for? Joints isn't right. Intersections. waveform collapse out from path to introduce variance. No, this will never, the goal of this is to never generate the same map twice. That would be for a run from a singular player within their same run. This would be for 2 runs between players. In theory, we could write our waveform collapse function in a way that will take a seed, so that we can get the same exact map each time. I think a better option would be to encode the algorithm, not the algorithm, encode the output for the algorithm into some sort of, byte data that can then be stored. So we can see a run and then a byte data array or something like that that is compacted down so that we could use it for debugging. And then we could, instead of generating a waveform collapse function to set everything up, we would do the reverse of it and take the serialized byte data and parse it back into a into the, so the waveform collapse is hydrating data to create tiles, and then our output would be to serialize that into data that we can store. The reverse of that would be to take the data that's stored and hydrate it into tiles, and that way we could use that to recreate the exact map someone saw. I think that would be the better way of doing it, though technically if we have one-way transforms that occur, that all bases off a seed, we could take in the minimal data to just recreate it, and then it would run in a one-way transform. That would be an option as well. That's harder to do. And again, we're doing this for a game jam, so we do have to keep in mind how long we want to spend on different things. I've pretty much burned through a third of the time I want to spend on procedural generation already, and we've got almost nothing. So I don't want to take on something that would be even more complex in that scenario. I think that's going to be too much for the amount of time we have available to us. All right. I need to call it for today. Depending on how things are going, I might hop on and do a little bit more work later tonight. Most likely, I'm just going to be doing some more research into variance on waveform collapse to see if there's someone out there that's done something similar to what I'm trying to do. But we'll see. It would be nice to have more information and more examples of people doing this. So we'll fiddle around. I'll fiddle around with that tonight. Yeah, I want to get something that's simple but expandable that I can then iterate on to refine and improve. Because if I can get something that works, it doesn't have to be great, but it works and I can expand it later, then we can move on to other things. And when we get through our polish, if we've got extra time, then we can start iterating. Again, game jam. So, but like I said, I gotta get going. I need to call it for today. I will be streaming again tomorrow. That is the plan right now. So if you guys are available, join me 10 a.m. Central. I should be able to do it first thing. 11 a.m. East Coast and 8 a.m. Pacific time. I uploaded the current build that we have going, minus the fixes we did today, to itch.io already, which is linked in the Discord. If you guys want to give it a try, it's mostly just character select and playing around with AI right now. So, which also needs to be refined and improved. But thanks for joining me, and we can pick this up again tomorrow. I am going to go ahead and try to trigger a raid on the Twitch side. Let's see who is online. Hypnotic Games is online. Masudi, I'll take a look at that pretty much as soon as I'm done here. But let's go raid Hypnotic Games. Seems to be the only one that's ever online when I finish my streams. So we end up raiding him quite frequently. So, all right. Again, thanks for joining me. If you guys want to join the raid and go check out Hypnotic, he's a cool guy. Yeah, I'll see you guys all tomorrow. Peace.
Storm. G'day, you good dunce. How yous doing? What were you up to this morning? I'm currently trying to figure out this game that has some sort of multiplayer. Riven. G'day, you good dunt. How you doing? We are crushing our bugs and whatnot. Crushing performance as well. I'm loving it. Absolutely loving it. Alternative, find a game where devs actually care about optimization, like me. Like me. Did some bug fixes on Psychocats for my game jam. Most of the stream was working on waveform collapse functions. Nice. Nice. I've never bothered to try those. I feel it will go over my head if I ask you to explain it. Like, very much just... Third person in-house, 2009. Fantasy comedy. Open world. What is this? Remember, with indie game devs, we should just get it done and performance tune once the MVP is running. Or you do things in an optimized way while you're making it. Like what I've done with like my item data being shared resources. So we don't have an item data instance for every instance of the object. They all share the same item data resource, and the only thing that we track external to that is what pricing the player has set for the item. Done. Performance would be so much worse if we had 8,000 item data objects or item data resources for the 8,000 objects. That would be... Oh, that would be a nightmare. That would take up so much more RAM. Yeah. Like, there's stuff like that that you can take note of, like, that you can do while you're developing it. But other performance tuning things, like graphical setting improvements and stuff like that, giving people the ability for like shadow detail control and stuff like that. Come on, we've got to figure out this game. It's a simulator from 2009 that's third person. Comedy, fantasy, open world. And action. Now, what was the first Don't Starve? That is 2014, and it's isometric bird view. When was Goat Simulator? Goat Simulator was Unreal Engine. I'm pretty sure. But I think the first Goat Simulator was more around... More in the 2010s. 2014. A simulator comedy RPG or comedy fantasy open world action. Overlord 2. Was that released in 2009? And is that third person or is that bird view? Yeah. It's actually pretty straightforward, conceptually. It boils down to 1. Picking a starting cell in a grid. 2. Choose the cell value based on all of your options, usually tiles, numbers, something. 3. Update all neighbor cells to limit them so they can't conflict on their tile choice. I'm already lost. 4. Choose your next cell based on who has the least options available to them. 5. Repeat until there's nothing left to collapse. I'm trying to do it without rigid bounds and on size, while ensuring a proper path to the exit. Is it open world though? Overworld, I mean. I don't think Overworld is open world. Too early? I know, big bit. I know. It's 9:30. It's so early. Think how you solve a Sudoku puzzle. Just as an algorithm. The way I solve a Sudoku puzzle, it's probably not a good way of solving it. But I get what you mean. Brutal Legend. Ooh, I like Brutal Legend. Brutal Legend's a good guess. Nicely done, Bok. Nicely done. Need to go handle dinner and check on my partner. Fair enough, Storm. Have a good one. Thank you for the raid.